Interior of Earth consists of, yeah, core, mantle and crust. Yes, so those are the three division we have discussed with regard to chemically divided and mechanically we have divided. Chemically we have divided into three parts. Chemically we have divided into the outer crust or crust part, mantle part, as well as core part, that is outer core and inner core. And mechanically we have divided into lithosphere, asthenosphere, mesosphere and baryosphere, which is the outer core and inner core. Clear? So those part we have covered in the last class. So what is lithosphere? Yeah, solid part of the earth or upper part of the earth. How much upper part? Yeah, 60 kilometer of crust and 40 kilometer of upper mantle. Those constitute a solid part. Then, yes. Yeah, it is not a continuous solid block, rather broken down into many plates. Clear? Major plate or minor plates. Then asthenosphere, on which the plates are moving. Asthenosphere is the layer on which these plates are moving. Clear? Then we also discussed the mesosphere. Mesosphere, as we discussed, can be in what? Can be in the solid state. And then we discussed baryosphere, which is outer core and inner core. Outer core we discussed was in liquid state, while the inner core is in solid state. Clear? So these formation we have discussed. Now there are certain questions which have been related to our last discussion. Can you answer question number 18, which has been asked in the examination? So he's saying consider the following electromagnetic radiation. It says electromagnetic radiation, geothermal, gravitational force, plate movement, rotation of Earth, revolution of Earth. Which of the following are responsible for bringing dynamic changes on the surface of Earth? What is responsible for bringing change on the surface of Earth? So on surface of Earth, what you are finding? You are finding mountains, you are finding what? Plains, plateaus, you are finding rivers flowing. So what changes, which of the following is responsible for these changes? Clear? Last class we discussed electromagnetic radiation means what? Electromagnetic radiation means what? From gamma rays to what? Radio waves. So this we have discussed, okay, which is called as what? Electromagnetic radiations. From gamma rays, X-rays, ultraviolet rays, UV, the visible rays, infrared rays, microwave and radio wave. This is called as what? This is called as your electromagnetic radiation. Clear? Now we discussed whatever phenomena that is taking place on the surface. Last class we discussed whatever the phenomena that is taking place below surface of Earth is taking place because of what? Because of Earth's heat. And we discussed Earth's heat is generated due to radioactivity. Clear? And whatever phenomena taking place above the surface of Earth is okay taking place due to sun's heat. We discussed sun's heat. So two things we have discussed: Earth's heat and sun's heat. Whatever phenomena taking place below the surface of Earth is taking place due to Earth's heat, which is generated due to radioactive decay, and whatever phenomena taking place above the surface of Earth is due to sun's heat. Clear? So one thing that is mentioned is a geothermal. Geo means what? Earth. Thermal means what? Heat. So geothermal energy is mentioned. So it is talking about which heat? Earth's heat. So Earth's heat is responsible for volcanic eruption. If volcanic eruption happens, will it mark a change on the surface or not? It will mark a change. Yes. Then we discussed sun's heat. Electromagnetic radiation means what we are talking about? Sun's heat. Sun's heat, remember we discussed the sun's heat coming mainly in the form of UV rays, visible rays. We talked about that in the last class. Clear? So sun's heat is coming in this form. When sun's heat is coming in this form, it is responsible for what? Sun's heat is responsible for what? As we discussed, weather phenomena, wind movement, other movement, rainfall, all the cyclones, all these are happening due to what? All these are happening due to the sun's heat. If cyclone occurs, other thing occurs, will it not disturb the changes on the surface of Earth? Will it not change? If rainfall, too much rainfall happens, what will happen? Flood will destroy everything. Will it not change the surface? Yes, it will change the surface. So even the first is okay, changing the surface. Even the second is something that is changing the surface. Just now in the last class we discussed this term rotation of Earth and revolution of Earth. What is rotation? On its axis, revolution on around the sun. So rotation and revolution we have discussed. Now rotation is responsible for what? Day and night. So you see, revolution is responsible for what? Seasons. Now if winter season, summer season, will climate will change or not? Will climate will change, then what will happen? Rainfall pattern, other pattern, all things will change. When all things will change, what will happen? It will also cause a change in what? Surface of Earth. So again, these two is also responsible for what? These two is also responsible for change on the surface of Earth. Now next we discuss plate movement. So plate movement we discuss is what? Major plate and minor plate. We discuss plates are coming together and moving apart, and we discuss because of plate collision what is generating? Earthquake are generating. If earthquake occur, what will happen? Surface will change, Earth's surface will change. It will lead to what? It will lead to, let's say if earthquake occur, what will happen? It will lead to nothing but mountain coming down. Size of mountains will what? Mountains may move downward also because of earthquake occurring. It may lead to avalanches. It may lead to landslide. That can be triggered due to what? That can be triggered due to the plate movement. Clear? Any doubt regarding this particular part? So even this is causing the surface changes. And lastly, gravitational force. We discussed gravitational force is responsible for what? Remember, we discussed Earth is in which form? Earth is in geoid form. It is what? Flattened over here, and it is bulging out. Okay, where? So why it is bulging out? Less gravity. Why it is flattened over here? More gravity. Last class we discussed more gravity is the reason why poles as you move towards pole, gravity will increase. So when gravity will increase, what will happen? You see the Earth is pulling that area more. So when that Earth is pulling this area more, what will happen? You see flattened surface. When Earth is pulling this area less, what will happen? You are seeing nothing but bulging out surface. So even gravitational force is responsible for what? Change in the surface. So all these forces are responsible for what? All these forces are responsible for dynamic changes. So answer here will be what? Answer here will be 1, 2, 3, 4, 5, 6. Clear? Any doubt? So these are the basic concept how the UPSC is forming a question in the examination. So whatever the forces we are studying, whatever the things we are studying, just remember how it is going to bring a change. Clear? $63, can you answer? Option B. Yes, option B is correct answer. Carbon, hydrogen, and nitrogen. These are responsible for what? These are responsible for origin of life on Earth. There are 5 elements, even oxygen and even phosphorus. These 5 together are responsible for origin of life on Earth. Carbon, hydrogen, nitrogen, oxygen, phosphorus. These 5 together are responsible for what? Life on Earth. Clear? So here sodium is being given, so you can rule it out. Hydrogen, oxygen are there, but sodium is not there. Here what is happening? Calcium is being given, though phosphorus and oxygen are mentioned. That's why you can rule this out option. Here what will happen? Potassium is given. That's why this is wrong. Clear? So carbon, hydrogen, nitrogen is the correct option. But if question is given like carbon, hydrogen, oxygen, then also it is correct. Carbon, phosphorus, hydrogen, then also it is correct. Clear? No, later on it has come. In the starting, it was not there. Clear? When Earth was formed, just now we are going to take up that. When Earth was formed, it was in the form of very hot lava. There was no possibility of life at that. As Earth has cooled down over a period of time, then you see the emergence of life form over a period of time. Okay? These five also constitute your what? These five also constitute your DNA. What is your DNA? You know that DNA is, without DNA, life cannot be possible. So DNA is constituting of these five elements: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Clear? So these type of questions are coming in the examination, that what are the responsive, what can bring a change, or what is the reason for evolution of life on Earth. Those type of questions you are getting in the examination. Clear? So as and when we cover the topic, we'll also cover the previous year question paper which has come in the examinations. Clear? So this part we have discussed in the last class. Earth's interior, we discuss Earth's interior is what? Outer crust, inner crust. Then we discuss upper mantle, lower mantle. This type outer, sorry, this is outer core, this is inner core. Clear? Now outer core and mantle, we discuss which discontinuity, Gutenberg discontinuity. Inner core, outer core, we discuss which discontinuity, Lehman discontinuity. We discussed in the last class why discontinuity is occurring. Why this discontinuity is occurring? Because of change of their forms. Anyone else? Because of wavelength. Anyone else? Why discontinuity is occurring? We discussed that as you are moving down, there is increase in what happening? Temperature. There is increase in pressure. There is increase in what? Density. Which is causing what? Which is causing the discontinuity. Clear? So last class we discussed when you are moving from one layer to another layer, what is happening? There's increase in temperature, there's increase in pressure, there is increase in density, as different region is made up of different materials. So we discussed crust is made up of what? Silicon, aluminum. Mantle is made up of silicon, Magnesium's outer core, inner core are made up of nickel, iron. Nickel, iron. Since they are made up of different material, we discuss what is happening. What is happening? As you are moving from one layer to another layer, what will happen? Density will change, material is changing, so density will change, and as a result discontinuity occur. That's why we discuss Gutenberg is a major discontinuity. Moho is which type of discontinuity? Major discontinuity. That's what we have written in the last class. Moho is a major. So when you are moving from crust to mantle or from mantle to core, major discontinuity is going to occur. But there are certain minor discontinuity also. Like we discussed, Conrad is a minor, Repethy is a minor, and Lehman is also a minor discontinuity. Minor occurs within a layer itself. Like within crust, outer crust and inner crust, which discontinuity is there? Conrad. Within upper mantle, lower mantle, Repethy discontinuity. Within outer core and inner core, you have Lehman discontinuity. Like we discussed, why minor discontinuity occur? Why minor discontinuity occur? What was the reason why minor discontinuity is occurring? Again, as we discussed, there is a slight change in what? Slight change in density, slight change in temperature. Why minor discontinuity is occurring? Minor discontinuity is also occurring due to slight change in what? Slight change in density, slight change in temperature, pressure. This is happening. Clear? So why slight change? As we discussed in the last class, if you are taking this much region, this is a radius of Earth. From here to this point is what? Radius of the Earth. So we have discussed how do you calculate volume? Like sphere volume, we discussed how do you calculate 4/3 pi r cube. This is a formula for calculating the volume of sphere. And we discussed density is what? Mass by volume. Density is what? Mass by volume. So we discuss if volume is more, what will happen? Density is less. So when we are calculating here to here, what is happening? More radius means what? More volume means what? More volume means what? Less will be the density. But when we are taking only this much point from here to here, then what will happen? From here to here, what is happening? Less radius means what? Less volume means what? More will be nothing but density. So there will be minor changes also happening in the density. Clear? So major discontinuity is occurring because of big changes in this one. Minor discontinuity is occurring because of what? Slight changes in this one. Clear? Any doubt regarding this particular thing? So these are okay. What? These are the types of discontinuity that we have covered in the last class. Clear? Any doubt regarding this particular thing? Now, so we have discussed in the last class regarding the crust, and we discussed crust is divided into what? Crust is divided into outer crust and inner crust. The upper part is called as outer crust, and lower part is called as a inner crust. Or crust also can be divided into continental crust and oceanic crust. Yes, that part also we have covered in the last class. So what difference we have written between continental crust and oceanic crust? Oceanic crust is thinner. Continental crust is what? Thicker. Oceanic crust is made up of which type of rock? Mafic rock. Yes. And continental crust is made up of felsic rock. And oceanic crust is what? More denser. Yes. Then the continental crust, which is less denser. So that difference we have discussed between continental crust and oceanic crust. So as we discussed, let's say this assumes is what? This assumes is a crust one. So here what will happen? You'll see continent also, that is mountain, etc. Here you'll see nothing but water also. Here you'll see water also. So this particular part is thinner. This particular part is nothing but thicker in nature. So continental crust is more thicker. Oceanic crust is what? Thinner in nature. Clear? So this part we have covered in the last class, and we discussed what do we understand by felsic and mafic. What is felsic rock? What is mafic rock? What is felsic rock and what is mafic rock? What is felsic rock? What is mafic rock? Yeah, felsic contains lighter element. What are the lighter elements? Like sodium, like potassium. Yes, okay. And what is mafic?
It contains iron.
Yeah, heavier element contains iron, magnesium. So this is okay. Iron silicate, we discussed silicate, it is going to form like iron silicate, it is going to form sodium silicate, potassium silicate. So those are okay. What those are we have discussed with regard to felsic and mafic. So rocks which are rich in lighter element like sodium, like we discussed aluminium, those are what? Those are nothing but okay felsic rock that are rich in heavier element like iron, magnesiums, those are called as a mafic rocks. So we discussed okay this particular part, oceanic crust as well as continental crust. Any doubt regarding this part? Now, so we discuss as we are moving from crust towards mantle region, we are seeing a discontinuity, and this discontinuity is referred as Moho discontinuity. Yes, why this discontinuity is occurring? As we discussed, due to increase in temperature, due to increase in pressure, due to increase in density. Now, crust has generally a density of around 2.3 gram per. It has a density of around this one. Clear? But when we are moving to upper mantle region, density increases from 2.9 gram to 3.3 gram. So when we are moving from the crust towards the mantle, you'll see a change in density. Density is going to increase from 2.3 gram per centimeter cube to 2.9 to 3.3 gram per centimeter cube. This is okay, the change that you are finding. So this much density is going to be there in the upper mantle region. Clear? So that's why you are observing this Moho discontinuity. Clear? Now, another important thing we discuss, crust is okay what? So we discussed this crust. We discussed crust only contains from where to where? From 0 to 60 kilometers. So we discussed crust is very small part, and that's why the crust constitute less than 1% mass of Earth and less than what? Less than 1% volume of Earth. So crust only contains less than 1% mass of Earth and it contains less than 1% volume of Earth. Clear? Major part that you find here. Now, what you are finding from 60 kilometer to 2,900 kilometer is what? Mantle region. This whole region is a mantle region. Now you are seeing major volume. Major volume is coming from where? Major volume of Earth is coming from mantle region. Major volume of the Earth is coming from mantle region, because core is having what? Core is having lesser volume as compared to nothing but okay mantle region. Clear? Major volume of the Earth is coming from mantle region. Clear? So in mantle is constituting around 83% of Earth's volume and roughly around 67% of Earth's mass. So it is constituting around 67% of Earth's mass as well as 83% of what? 83% of Earth's volume. Clear? So that's why we are observing this major discontinuity. That's why we are observing this major discontinuity. Clear? So this difference you have to keep in mind with crust and mantle. Crust constitute less than 1% mass of the Earth. Less than what? Less than nothing but okay 1% volume of the Earth. The much of the volume of the Earth comes from where? Mantle, that is 83% of the Earth's volume and 67% of Earth's mass. Clear? Now why this is happening? Why this is happening? Why this is happening? Remember, we discussed the rotation. When rotation will happen, what will happen? Heavier element will come where? Towards the center. Lighter element are going to what? Going to move away. So crust is what? Crust is going to be lighter element, move away, while the mantle and core is going to contain what? Heavier element. That's why much of the mass, much of the volume is coming from where? Coming from mantle and the core region. Clear? Any doubt regarding this particular thing? Now, this particular mantle region, as we discussed, contains what? Contains a asthenosphere, and we discuss asthenosphere is where plates are moving. So we discuss 100 to 200, generally around this kilometer you are finding what? Asthenosphere. And on this this asthenosphere is in which state? It is in plastic state, over which plates are something that are moving. Clear? Another important, as we move from upper mantle to the lower mantle, upper mantle to the lower mantle, which type of discontinuity we have discussed? We have discussed Repethy discontinuity. Yes. So when we are moving from upper to lower mantle, which type of discontinuity we have discussed? Repethy discontinuity. Now, why this discontinuity is occurring? Again, because of change in what? Change in density, change in temperature, change in pressure. But this is slight change, okay? Slight change that you are finding. On lower mantle, you will find around density increasing up to 5.5 gram per centimeter cube. So from 3.3 gram, it increases up to 5.5 gram per centimeter cube. Clear? So as we are moving from 60 kilometer, that is upper mantle, to 2,900 kilometer, that is lower mantle, you will see density increase from where to where? From 3.3 gram per meter per centimeter cube up to 5.5 gram per centimeter cube. You will see an increase in case of what? Increase in case of the density. Clear? Any doubt regarding this one? Now, that's why the density increase is uniform. Generally, you'll find density increase from the crust towards till the core. The density is increasing from crust till the core. Density is something that is increasing, and this increase in density is going to be uniform. But there is a temperature also. Temperature increase is not uniform. Temperature increase is non-uniform. So as we are moving from where to where? As we are moving from crust till the core, the density is going to increase in a uniform manner, while the temperature is not going to increase in a uniform manner, rather it increase in a non-uniform manner. Clear? What is uniform and what is non-uniform?
Continuous and then sudden.
Continuous and then sudden. Any other difference? What is the difference that you find between uniform and non-uniform?
So stagnant position.
Stagnant position is what? Uniform. And generally you have studied this type of graph in physics, no? This type of graph you have studied in the physics and etc. What does it indicate? When you cover, let's say this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So you take this as a time axis, you take this as a distance axis. Now what is happening is, if you are in 1 second, if you are covering 1 kilometer, in 2 seconds if you are covering 2 kilometer, what is okay there? It is indicating a uniform motion. It is indicating a uniform motion. You are covering equal interval, equal distance in a equal interval of time. That type of things is called as a uniform motion. Clear? So in case of what? In case of here, you are seeing, let's say this is what? 1. This is nothing but 2. This is 3. This is nothing but 4. Let's say this is a 0.5 kilometer. This is nothing but 1 kilometer. This is nothing but 3 kilometer. This is 9 kilometer. So here within 1 second you are only covering 0.5. Within another 1 second you are covering 0.5. Then you are covering around 2 kilometer. Then you are covering around 6 kilometer. So here the increase is what? Increase is non-uniform. Clear? So that is what difference lies between uniform and non-uniform. Clear? Uniform means equal interval, you are covering equal, okay, what equal things, equal increase is happening in equal time interval. Here also what will happen is, okay, equal interval is, equal increase is not happening in equal time. So this is how the motion you have studied regarding uniform and non-uniform motion. Now the same also applies to what? Same also applies to the earth. Now we are taking on one side what? On one side we are taking temperature, on one side we are taking kilometer. Clear? So on one side we are taking temperature, on one side we are taking kilometer. Clear? Now as we are moving down, every kilometer, whether temperature is increase is uniform or whether temperature increase in non-uniform. We just now discussed temperature increase is non-uniform. So every kilometer as we are moving down from 0 to, so from here when we are moving down from 0 to 60, when we are going down, what is happening? With every kilometer increase, the temperature is variation is, okay, what? Temperature variation is not equal. Why it is not equal? Why it is not equal? Remember last class we discussed convective current, convectional current in, okay, inside what? Inside the mantle region. What was convection? Conduction, convection, radiation, we discussed, okay, that concept. What was convection? In which molecules itself move from what? From nothing but, okay, bottom to top. Convection generally occurs where? In fluid, that is in liquid and gas. And we discussed molecule itself move from where to where? From nothing but, okay, bottom to top. That was convection. And we also discussed something called conduction. Conduction happens where? In solid. And we discussed, okay, in conduction molecules do not move. In conduction molecules do not move. They vibrate on their own position. That is what we have discussed regarding. So here in the mantle region, we discussed what is happening. So in mantle region, what is happening? We discussed convectional current are being generated. And why this convectional current are generated? This is responsible for Earth's heat. Like we discussed, two heats are there, Earth heats and Sun's heat. So why Earth's heats are there? It is because of nothing but, okay, convectional current that are generated in the mantle. And why this convectional current are there? Why this convectional current are generated? We discussed last class, radioactive decay. What is the reason behind generation of this convectional current? We discussed radioactive decay. This radioactivity is causing what? Causing release of heat, and this heat transfer is happening in the form of what? In the form of convectional current. Clear?
So what is radioactive?
Like uranium, any radioactive material is what? Going to decay. Clear? In periodic table, any heavier element greater than 83 is going to show what? Is going to show phenomena of radioactivity. What is radioactivity? What is radioactivity? As we discussed, atom is consisting of what? Neutron and proton. Neutron and proton inside nucleus, and electrons are what? Revolving around nucleus. Clear? Now, as we discussed, periodic table like hydrogen, helium, lithium, beryllium. So we discuss hydrogen has a 1 atomic number, helium has what? 2 atomic number, lithium has 3 atomic number, beryllium is what? 4 atomic number. What is this atomic number indicate? Yeah, atomic number indicate either number of electrons or number of protons. Clear? Either number of electrons or number of protons. This is indicated by whom? Atomic number. So hydrogen has how many electrons? 1 electron. And how many proton? 1 proton. So this negative and positive charges are what? Balancing each other. If one negative charge and one positive charge is balancing each other, and as a result, atom as a whole is what? Electrically neutral. Atom as a whole has no charge. Why atom as a whole has a no charge? Because positive charge is balanced by who? Negative charge. Clear? Helium is how many? Helium is having how many electron? How many proton? 2 electron and 2 proton, and that's why this is okay. What? This is nothing but okay. Again, electrically neutral. So if positive and negatively charged are going to balance each other, then the atom is going to be called as a electrically neutral. Clear? What if positive charge increases? Let's say two protons are there, and let's say only 1 electrons are there. If positive charge increase, then what will happen? If positive charge increase, then what will happen? Then only one charge is being balanced, the other charge is not being balanced. So what will happen? This, okay, will acquire a positive charge. This will acquire a positive charge. If positive charge increases, how much it is increasing? 1, so it will acquire 1 positive charge. Clear? Like you have HCl, no? You have HCl is what? Hydrochloric acid. You have H plus and Cl minus. So if number of electron increases, let's say 3 electrons happens and 2 protons are there, then it will acquire what? A negative charge. It will acquire a negative charge because electrons are more than what? Protons. So it will acquire a negative charge. So this type of, and you know that positive and negative charge are going to what? Attract each other. So this type of bonding is occurring, and that's why you see what is being formed? Hydrochloric acid are formed. So this, when any substance acquires positive charge or any substance acquires a negative charge, then it is called as what? Then it is called as what? Ions. Okay, so atoms are what? Atoms are electrically neutral. When atoms either gains a electron or loses an electron. Clear? Either lose, if it lose an electron, then what will happen? Electron will become less and proton will become more. So that's why atom will acquire what? Positive charge. If it gains an electron, then what will happen? Electron will become more than what? Proton. If it becomes more than proton, then what will happen? Negative charge. Okay, so that's why you see chlorine is acquiring a electron. So chlorine is what? Gaining electrons. Chlorine is getting negative charge. Hydrogen is losing an electron, so hydrogen is becoming nothing but positively charged. So that's why this bonding is happening. This is called as a ions. Okay, so atoms is there, ions are there. Clear? And inside the nucleus, we discuss what is present. Protons are something that are present. So hydrogen, as we discussed, has how many proton? 1 proton. Helium is having how many proton? 2 protons. Lithium is having how many proton? 3 protons. Beryllium is having how many proton? 4 protons. Now, when more positively charges are going to be there, what will happen? Because inside nucleus, what is happening? More protons are there. More protons means what? More protons means what? We discussed like charges are going to what? Like charges are going to repel each other. Unlike charges are attracting each other. When positive and negative charges are there, unlike charges are what? Attracting each other. Like charges are going to what? Repel each other. So positive is going to repel each other. Positive, negative is what? Attracting each other. So this is what? This is unlike charges. This is nothing but what? Like charges. Like charges are repelling. Unlike charges are what? Attracting. Clear? So that's why you see opposite attracts. You heard about this term, no? Okay, when you are what? When you are nothing but thinking about couples and etc. Opposite couples attract. Why? Because different things are there. So different personalities are there. So why this is happening? This is what electromagnetic concept is there. When like charges are what? They are going to repel each other. Unlike charges are going to what? Attract each other. So when more number of protons are there, then what will happen? More repulsion. More repulsion means what? More repulsion means nucleus becomes unstable. Nucleus becomes unstable because nucleus is binding this proton and neutron. Clear? But when more repulsions are going to be there, then nucleus will become what? It becomes something but unstable. When nucleus becomes unstable, then what will happen? When nucleus becomes unstable, then what will happen? This will what we call as goes under radioactive decay. Clear? So when nucleus becomes unstable, why it becomes unstable? Because more number of protons are there, more repulsive force are there, and as a result nucleus becomes unstable. When it becomes unstable, then you see alpha, beta and gamma rays are going to be released from this nucleus, and this is what we call as a radioactivity. Clear? This is what we call as a radioactivity. So as we discuss, any element above 83 in periodic table is going to show phenomena of what? Is going to show phenomena of radioactivity. Why 83? Because how many protons are there? 83 protons. 83 protons means what? More repulsion. More repulsion means what? It will show phenomena of what? Radioactivity. Clear? So that's why uranium is generally showing phenomena of what? Radioactivity. Thorium, it is showing phenomena of what? Radioactivity. Clear? So that's why you use these where? You use these in nuclear fission process. You use this where? In the nuclear fission process. Okay, you generate electricity from nuclear energy, no? So how you generate electricity from nuclear energy? By nothing but okay, breaking the bigger nucleus into two smaller nucleus. Why bigger nucleus is broken down? Because it is unstable. Okay, bigger nucleus is unstable. Why it is unstable? More number of proton. More number of proton means what? More repulsive force. So because of this, the bigger nucleus is what? Bigger nucleus is unstable, and that's why when bigger nucleus break down into two smaller nucleus, then what is okay being released? And nuclear energy is being released. Clear? Any doubt regarding this particular thing? So since Earth contain many radioactive element, no, uranium from where you mine? From the Earth. Thorium from where you mine? From the Earth. So when Earth contains many radioactive element, what will happen? They will show radioactive decay, and when they will show radioactive decay, what will happen? Energy heat is going to be released. This energy heat is going to cause what? This energy heat is going to cause convectional current. Clear? Decay means okay, the breaking down. Okay, you see breaking is happening, no? This is breaking down. So original material is not there, no? It has become what? Different material. After breaking down, it has become different material. So that is what we call as a decay. Clear? Decay means what? Growth is not happening, degrowth is something that is okay happening, material is declining. So this bigger material has been declined into two smaller material that is okay there. Clear? Any doubt regarding? So this is what we call as a radioactive decay. Clear? So this radioactive decay is okay, what? Radioactive decay is causing this convectional current. You have studied about a formula. This formula you have studied, E is equals to delta mc square. What is delta? E is equals to, E is what? Energy. This is energy. Delta is what? Delta is small change in mass. Small change in mass. And C is what? Velocity of light. C is what? Velocity of light. Clear? So this bigger nucleus, let's say its mass is around 3 gram. Let's say its mass is around 3 gram, and combined mass of this smaller nucleus is, let's say, around 2.9 gram. When it is breaking down, the combined mass of nothing but okay, two smaller nucleus is what? 2.9 gram. This difference in mass, that is 0.1 gram, is being converted into what? Is being converted into energy. Okay, this difference in mass is being converted into energy. Which energy? Heat energy. Heat energy is causing what? This heat energy is causing the generation of convectional current. Clear? Any doubt regarding this particular thing? So this is what we call it as a radioactive decay or radioactivity. Clear? So that's why there are certain places on the earth where you'll see what? Where you'll see more radioactivity, because more radioactive materials are present over there. There are certain places where you see less radioactivity because less radioactive material are present. That's why temperature increase is what? Temperature increase is non-uniform. Temperature increase is what? Non-uniform, because of more heat is going to be released, more temperature is going to be there, less heat is going to be released, less temperature is going to be there. So that's why temperature increase in non-uniform. While we discussed which is going to be uniform, density is okay going to be uniform. There will be what? Increase in density in a uniform manner. Clear? So let's say if question comes like this, What is the answer? Is that B? Both. So here it's saying as we go deeper, the density increases in uniform manner from crust to core. Just now we discussed density is going to what? Uniformly increase. So first statement is what? Very much correct statement. Second, as we go deeper, the temperature increase in a non-uniform manner. Yes, we discussed temperature will increase in a non-uniform manner. With slow increase from crust to mantle, no. There will be faster increase from crust to mantle, and from mantle to core there will be what? Slow changes in temperature. From mantle to core there will be slow changes in temperature. So first there will be huge increase, then after there, okay, slow increase will be there in the case of nothing but, okay, temperature. Clear? Any doubt regarding this one? So second is wrong statement, first is correct statement. Clear? So as we discussed, crust, this part is crust, this part is a mantle. Mantle is where you see what? Mantle is where you see what? Radioactive decay. So here what will happen? Temperature will be more, no? So when you are moving from here to here, what will happen? Faster changes in temperature. And then from here to here, what will happen? Slow changes in temperature will happen. That is okay there. Clear? Any doubt regarding this one? So this type of questions can be found in case of examination. Clear? So what you have to keep in mind is when you are moving from crust towards the core, what will happen? What will happen? Crust towards the core, density will be uniformly increasing, but the temperature will be non-uniformly, with more increase in crust to mantle and lesser increase from mantle to core. Clear? Now, one more thing. So we discussed as you are moving from where to where, from crust to mantle, discontinuity is being observed, and within mantle we discuss lower mantle, upper mantle and lower mantle. You'll see a discontinuity. Clear? Now crust, if you see crust, we discuss crust is made up of what? Silicon and aluminum. Clear? But silicon and aluminum exist in which form? Are they existing alone? You know that any element or any material exists in certain bonds. Okay, like we discussed, hydrogen exists in the form of what? H2O. So you see certain bonds are something that are present. So this silicon is existing in which form? Silicon is combining with the oxygen. Aluminum is combining with whom? Oxygen. Clear? So they are existing in what? They are existing in bonding form. Clear? Just now we discussed, okay, electrovalent bonding, where opposite charges are what? Attracting each other. So similar type of bonding is okay. Another type of bonding is called as a covalent bonding. Another type of bonding is called as a covalent bonding. Clear? So covalent bonding, generally oxygen. Oxygen is existing in which form? O2 form. Clear? So you will see oxygen, like what is covalent bonding? I'll just explain it. Oxygen has an atomic number of whom? It has a, no, mass number is 16. Atomic number is what? Atomic number is 8. It has an atomic number of 8. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. It has an atomic number of whom? Atomic number of 8. Clear? How many electrons it is going to have? 8 electrons. What you see is, okay, this has 8 proton inside the nucleus and it will have 8 electrons. So first electron, first shell. Remember last class we discussed Neal-Bohr model. Neal-Bohr model is giving what? That electrons are revolving in what? In a shell. Okay, we discussed Dalton's, okay, said that what? Atom is indivisible. Then we discussed second model was Thomson model. Thomson says that no, atom consists of electron, proton. We discussed Rutherford came. Rutherford says that what? that neutron and proton are inside nucleus while electrons are revolving around the nucleus. And finally, we discuss Neal-Bohr model. Neal-Bohr model says what? That electrons are revolving in a shell. Clear? So first shell contains how many electron? First shell contain 2 electron. Okay, the maximum electron that first shell can contain is how much electron? 2 electron. The second shell contain maximum of how many electron? They can contain maximum of 8 electron. The first shell can contain maximum of how many electron? 2 electron. The second shell contain maximum of how many electron? 8 electron. But oxygen has how many electron? Total of 8 electrons. So first shell has already taken 2 electron. So in second shell, how many electrons are going to be there? 6. 1, 2, 3, 4, 5, 6. So this 6 electron is going to be in second shell and 2 electron is going to be in the first shell. Total of how many electrons are there? 8 electron. Clear? Now, an atom is not stable. An atom is not stable till all the 8 electrons are there in the outermost orbit. It has to have all 8 electron in how many outermost orbit. If it is not having 8 electron in outermost orbit, what will happen? It is not stable. It is not going to be stable. Clear? So that's why we discussed, let's say hydrogen. Hydrogen has how many electron? 1 electron. If it loses this electron, it requires what? Positive charge. Clear? Now chlorine has how many electrons? 17 electrons. So we discussed first have how many shell? 2 electron. The second can accommodate how many electron? 8. The third can accommodate how many electron? 8. But okay, the chlorine only has 17. Chlorine only have 17. So 2 plus 8 plus 7. Chlorine octet is not complete. So chlorine requires 1 more electron to complete its octet. Hydrogen loses this electron and give it to whom? Give it to the chlorine. So that's why this bonding is something that is okay there, which is called as a H plus and Cl minus. Clear? But in case of oxygen, octet is not complete. Okay, 8 electrons are not there. How many electrons are there in the outermost orbit? 6 electron. But what it can do is what? What it can do is it can share the electron. So this, it has how many electron in the outermost orbit? 6 electron. And take another oxygen atom. How many electron it will have in outermost orbit? 6 electrons. So it has how many orbit? 1, 2, 3, 4, 5, 6. It has how many? 6 electron in the outermost orbit. Now they will share these 2 electron. They will share these 2 electron with each other. Clear? So how many electron now this oxygen will have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so its octet is now complete. How many it will have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it also have now 8 electron in the outermost orbit. So this type of bonding is okay, double bonding. So that's what we call as a O2. That's what we call as a O2. So this type of bonding is called as what? Covalent bonding. Clear? So either you can have this type of bonding, which is called as a electrovalent bonding, or you can have okay this type of bonding, which is called as what? Which is called as a covalent bonding. In electrovalent bonding, what happens? One lose electron, another gains electron. Clear? No one loses, no one gains. Only what will happen? We share electrons with each other. That type of bonding is called as what? Covalent bonding. Clear? Not getting? Not getting. Clear? So if you're not getting, just ask me. Okay. Clear? What we are saying that how many electrons are there in the outermost orbit? How many total electrons are there with the oxygen? 8 electrons. Clear? Now, as per we discussed, okay, as per this thing, how many are going to be what? How many are going to be there in the first orbit? Only 2 electrons can be there in the first orbit. Clear? Only 2 electrons can be there in the first orbit. Clear? How many maximum can be there in the second orbit? 8. Second can be maximum 8 can be there in the second orbit. Clear? Now oxygen has total of how many electron? 8 electron. So in the first orbit, what has happened? 2 electrons has been there. So how many is left now? 6. So in the second they will have how many electron? 1, 2, 3, 4, 5, 6. Now oxygen has this 6 electron in outermost orbit. Clear? But how much maximum it should have? 8. It will become stable only when it has 8 electron. Till the time it is not having 8 electron in the outermost orbit, oxygen is not going to be stable. Then oxygen will react with what? Another element. Okay, if it is not having 8 electron in the outermost orbit, then it is not stable. It is going to react with another element. Clear? So that's why, since it has a 6 electron in the outermost orbit, we'll take another oxygen atom which is also having 6 electron in outermost orbit. Now what is happening? These both are sharing electron with each other. So now how much it is? It will have 1, 2, 3, 4, 5, 6, 7, 8. It has how many electron now? 8 electron. It will 1, 2, 3, 4, 5, 6, 7, 8. Now it has also how many electron? 8 electron. So now both had 8 electrons, so both are going to be what? Stable. Okay, because their outermost orbit is now filled, so they are going to be stable. Such type of bonding, because 2 electrons are shared, so we'll have double bond. Okay, 2 electrons are shared, then we'll have, okay, what? Double bond. If 1 electrons are shared, because here we are sharing 2 electrons, okay, if 1 electrons are shared, then what will happen? Single bond. Clear? If 3 electrons are shared, then which type of bond? Triple bond. Clear? Any doubt regarding this particular thing? So here how many electrons are being shared? 2 electrons are being shared. Okay, here 1, 2 electron. Why 2 electron? Because these 2 electron is already with this oxygen atom. No, it has how many electron? 1, 2, 3, 4, 5, 6. How much it is sharing with other? 2 only. So that's why it has how many electron? 8. It is not sharing 4. It is only sharing 2, because already 2 it has. It is sharing another 2. That is okay there. Clear? And this also have, okay, how many? 1, 2, 3, 4, 5, 6. It is taking how much? 2. That's why double bonding is okay there. So this O2 is stable. Clear? So that's why oxygen do not exist in O form. Oxygen always exists in what? O2 form, because its octet is not complete. Clear? Any doubt regarding this one? So when we share the electron, this type of bonding is called as what? Covalent bonding. Yes. And when we don't share the electron, when one loses electron, one gain electron, then this type of bonding is called as a electrovalent bonding. This type of bonding is called as a electrovalent bonding. Clear? Any doubt regarding this one? Clear? So what you see is, that's why we discuss silicon, aluminum, these octet are not complete. Why? Because we discuss oxygen, then after oxygen what comes? Fluorine, what comes? Neon, then sodium, potassium, aluminum. How much is aluminum atomic number? 9, 10, 11, 12, 13. How much is atomic number of aluminum? 13. 13 means how many electron it will have? First orbit, how many electron? 2 electrons. Second orbit, how many electron? 8. Maximum 8, because it has how many? It has how many? 13. Okay, so it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is over. Now the third orbit will have how many? 3. Okay, how much is left? 3 is left. So its octet is not complete. When octet is not complete, what will happen? It will react. It will react means it will react with whom? Another element. So that's why it reacts with nothing but, okay, oxygen. That's how silicon also react. That's how aluminum also react. So they are not existing in what? They are not existing silicon as itself or aluminum as itself. They are reacting with whom? They are reacting with other element and existing in bonding form. Clear? Any doubt regarding this particular thing? Anyone having any doubt? So when it is existing in bonding form, if question comes, what is the most abundant element in the earth crust? What is the most abundant element in the earth's crust? Then what you are going to write? The most abundant element is oxygen. Why? Because oxygen is also existing with whom? Silicon. Oxygen is also existing with whom? Aluminum. So most abundant element in the earth's crust. Okay, just note it down. Most abundant element in the earth's crust is what? Most abundant element in the earth crust is oxygen. So 46%, 40 in bracket you can mention 46%. 46% of earth's crust is oxygen only. Then followed by silicon. Silicon is 27%. Followed by silicon, 27%. Then aluminum, around 8%. Then aluminum, around 8%. And then iron, around 5%. Around iron. So we discussed core is consisting of what? Core is consisting of nickel and iron. So iron is present where? In the core. But iron is also present where? In the crust also. Why? How it is present on the crust? How it is present on the crust? Yeah, it is present in the bonding, but how it is present? How it is present? Just now we discussed, no? Oceanic crust is what? Mafic. Mafic means what? Iron. Continental crust is what? Felsic. Felsic means what? Silicon, silicate, sodium, potassium. So what is happening? Okay, oceanic crust is made up of whom? Iron. So iron is also present where? In the crust. Iron is, though majorly we are saying silicon and aluminum. Sial, okay, it is called as a silicon and aluminum. We have written crust is made up of what? Silicon and aluminum, because silicon is how much? 27%. Aluminum is how much? 8%. Maximum concentration in crust is what? Maximum concentration in crust is silicon and aluminum. That's why we call it as a sial. But silicon and aluminum exist in bonding with whom? Exist in bonding with the oxygen. So that's why oxygen is the most abundant element in what? Oxygen is the most abundant element in the earth crust. Okay, 46% of earth crust is made up of oxygen, followed by whom? Followed by silicon, followed by aluminum. Clear? Any doubt regarding this particular thing? So if question comes that iron is present in the crust, don't mark it wrong. Okay, why? Because it is present in the crust also. Why? Because oceanic crust is made up of what? Oceanic crust is made up of nothing but, okay, iron. Clear? Any doubt regarding this particular thing? Yes.
So, we have iron.
Yeah, they do iron mining.
So, how do we do it?
How they do it? By digging. You can do.
Iron is also present on the crust, right?
Yeah, so that's what we know. Iron is present on the crust. Okay.
Oceanic crust is supposed to be under ocean.
Yeah, under ocean.
So, iron mining is done under ocean.
Yeah, remember first class we talked about polymetallic nodules.
Yes, sir.
Okay, so polymetallic nodules, what you are getting?
But
Metals. What are the metals? Copper, iron. Okay, those metals are something that are present inside the oceans. Okay, volcanic eruption happens. Volcanic eruption are going to take material from where? From below the earth to the top of the earth. So when, okay, volcanic eruption is happening, iron is present inside, okay, core, iron is present inside the mantle. From this, iron is going to come on what? Onto the surface. Okay, so on land also you can get iron. On the, okay, oceans also you can get iron. Okay, any doubt regarding this particular thing? So that's why oceanic crust is made up of what? Iron, because, okay, more of volcanic eruption happens. Okay, anyone having any doubt? So remember, we discussed continental, the crust is most abundant element in crust is what? Most abundant element crust is oxygen, followed by whom? Silicon, followed by aluminum. Why we have written sial? Why we have written crust is made up of sial? Because major element is silicon and aluminum, but silicon and aluminum do not exist alone. They exist in a bonding form with oxygen, and that's why oxygen is a most abundant element that is okay. Clear? Any doubt? Now mantle is made up of what? Magnesium. Okay, so we discuss CMA, silicon and magnesium that are going to be present in what? That are going to be present in the mantle region. So mantle is also consisting of what? Mantle is also consisting of silicon, magnesium. It is also consisting of iron. These materials are something that are present inside what? These are present inside the mantle region. Clear? So that's why mantle is said to be made up of what? Mantle is said to be made up of silicate. Silicate rocks of magnesium and iron. Mantle is supposed to be made up of what? Silicate rocks of magnesium and iron. Clear? So crust is made up of what? Crust is made up of silicon and aluminum, and along with oxygen. So oxygen is the most abundant element in the crust. Clear? Mantle is made up of what? Silicon and magnesium along with iron. So that's why we call it as a silicate rock, because silicon means silicate rocks of magnesium and iron. Clear? Any doubt regarding this particular part? Now, again, when we are moving from mantle towards core, what is happening? Yes, all density changing, temperature changing, pressure changing. This is creating what? Discontinuity. This discontinuity is referred as which discontinuity? Gutenberg discontinuity. This referred as a Gutenberg discontinuity. Clear? Now, remember we discussed mantle constitute how much mass and how much volume? How much mass? 83% of what? Volume and 67% of mass. So how much is left? How much is left? Core roughly constitute around 17% of what? Volume. And how much of mass? Around 33% of what? Mass. So core is constituting around how much of volume? Around 17% of nothing but okay volume, roughly. And how much of mass? 33% of mass. Clear? Any doubt regarding this one? So total 100% are there. If it is containing 83% volume, the roughly around 17% is going to be there with okay the core. And we discussed okay crust is only containing less than 1% of what? Volume, less than 1% of nothing but okay mass. So this is roughly 83%. This is going to be roughly around 17% of volume. And how much mass the core is going to get? It okay 33% of mass. Clear? Any doubt regarding this part? Now the core is consisting of whom? Core is consisting of nickel and iron. So core is consisting of nickel and iron. The major thing that you are finding in the core is nickel and iron. And as we discussed, core is divided into outer core and inner core. Core is divided into outer core as well as inner core. Outer core means it is in which state? Liquid stage. Inner core is in which? It is in solid state. Yes. Outer core is in liquid state while inner core is in solid state. Clear? Now we discussed earths also have what? That's why since earth core is made up of what? Earth core is made up of the iron. Earth crust is also made up of nothing but okay some part of there is iron. So if question comes, which is the most abundant element in the earth? Which is the most abundant element in the earth? Not crust. Okay, if it is coming most abundant element in the earth crust, then oxygen. But if it is coming most abundant element in the earth, then it is going to be what? Iron. Yes, most abundant element. Okay, note it down. Most abundant element in the earth is iron. Most abundant element in the earth is iron. Clear? So in bracket you can mention around 34.6%. Around 34.6% iron is there in the earth. Oxygen, second most abundant. Second you can mention oxygen, around 29.5%. Around 29.5%. Third, silicon around 15.2%. Fourth, magnesium around 12.7%. And then rest are nickel and other element that you have. So these are the top four material inside the iron is the first 34.6%. 34.6%. Okay. So be clear when you are reading, see the questions, whether it is mentioned earth crust or whether it is mentioning entire earth. If entire earth we are taking up, iron is the most abundant. If only crust we are taking up, then which is the most abundant? Oxygen is the most abundant. Clear? So the outer core is in which state? Outer core is in which state? It is in liquid state. Clear? Now when earth, as you know that earth is rotating, when earth is rotating, what will happen to this liquid? It will also nothing but okay move. Anyone have a transparent bottle? Transparent water bottle. No one is having transparent water. Okay, take transparent water bottle and rotate it. What will happen? You'll see liquid inside that bottle will also be nothing but okay rotating. Clear? So because of this, okay, what outer core, which is in liquid state, you'll see when solid is rotating, let's say when solid is rotating, what will happen with the solid? When solid, any solid material is rotating, what will happen in the solid? Mass shift will not happen. Mass shift will not happen. Clear? Solid will have a definite shape, definite size. So that's why mass will not move from upper to nothing but okay bottom. There will be no change in mass. But when liquid is moving, what will happen? You'll see nothing but okay change in mass. Some part okay what? Some part okay will go up. Some part will move down. Okay, change in mass will occur. That is okay there. Clear? So that's why when since outer core is in which state? outer core is in liquid state. When Earth is rotating, this liquid is also rotating. So some part you are finding more liquid, some part you are finding less liquid, that is okay there. And because of this, okay, what is happening? Because of which there is a generation of magnetic field. Because of this, there is a generation of which type of field? Magnetic field. Clear? Any doubt regarding this one? So how magnetic field are generated? Any moving iron, moving other things. When okay, any magnet is moving, then okay, what will happen? It will generate a magnetic field around it. Okay, that is okay there. So Earth has a magnetic field. Why Earth has a magnetic field? Because it liquid core is something that is okay rotating, and this magnetic field is not uniform. Why it is not uniform? This magnetic field is not uniform. Why it is not uniform? Because mass is changing. Continuously the mass is changing. Liquid is shifting from one place to another place. So its mass is changing, and as a result, okay, this magnetic field is something that is not uniform. At different places, you'll find different magnetic field. Okay, at different places, you'll find different magnetic field. So this is generating because of what? This is generating because of nothing but okay, this okay, outer core. Another reason, since Earth is rotating, we say another force is developed which is called as a Coriolis force. Coriolis force. Coriolis. Coriolis. Coriolis force. So this force is also generating. Clear? Now what is Coriolis force? Distribute the air. Anyone else? What is Coriolis force? A force that is generated due to rotation of Earth. Okay, so a force that is generated due to rotation of Earth is going to be called as what? Coriolis force. Let's say if an object is static, if I'm throwing this object, it should go to where? Or if I'm moving from here to here, it should go over here, no? Clear? So if it is a static, not rotating, if I'm moving from here to here, I should go nothing but okay at this point. But if things are rotating and I have to go to this point, then what will happen? I'll not move in a okay this direction. I have to move okay what in this direction, because this is constantly moving, constantly nothing but okay rotating. Clear? Any doubt regarding this one? Let's say so. Let's say this is okay what this is nothing but okay two things. Now assume this is a point. Now you are okay going through. You are starting from here to reach to this particular point. Now what will happen? Because Earth is rotating, now this point has moved where? This point has moved over here because Earth is rotating. So now, okay, you have to what? You can't move like this. You have to deflect from your position to reach what? To reach to nothing but okay, this particular point. This deflection is causing due to what? Coriolis force. This deflection is okay occurring due to what? Occurring due to Coriolis force. Clear? Any doubt regarding this particular thing? So force that is generated due to rotation of whom? Rotation of Earth is called as what? Called as a Coriolis force. So since Earth is rotating, liquid inside Earth is also rotating. This liquid inside of the Earth, as well as okay, any object when it rotates, as we discussed, which force is going to be generated? Coriolis force is generated. So Coriolis force plus okay what? Plus nothing but okay, liquid rotation is causing the generation of which? Generation of magnetic field of the Earth. Clear? So what is responsible for generation of magnetic field? What is responsible? Liquid core plus Coriolis force. Okay, so liquid core plus Coriolis force is responsible for generation of magnetic field. Clear? Any doubt regarding this particular thing? Clear?
Two.
2 only. So first statement says Coriolis force is the force generated due to revolution of Earth. Is it correct? No. What is the problem? Rotation of the Earth. Okay, so Coriolis force is generated due to what? Rotation of Earth. Second, Earth's liquid core is responsible for the eruption of magma. Okay, is it correct? No. Why it is not correct? We discussed the why the magma is formed. Magma is formed because of mantle. In mantle region, what is happening? Convectional current. Convectional current in the mantle region is responsible for what? Magma. Clear? So convectional current, we discussed convectional current as what? Molecules moving from what? Top, okay, bottom to the top. And if it is stronger, it comes out in the form of what? It comes out in the form of nothing but, okay, volcanic eruption. So the Earth's liquid core is not responsible for nothing but, okay, formation of whom? Formation of magma. What is responsible for formation of magma? The convectional current that are generated in the mantle region is responsible for nothing but, okay, formation of magma. So here
Expansion, one of the reasons.
this can't, no, this is also not one of the reasons. Okay, this is also not one of the reasons. Clear? Earth's liquid core, no,
So the magnetic comes out of the volcanic comes from the mantle.
yeah, it comes from the, no, it doesn't come from the core, it comes from the mantle region. Clear? Clear? So that's why it is going to be what? Neither one nor two. Both statement are something that are wrong statement. Clear? Any doubt regarding this particular thing? So such type of questions will form in case of examinations to check your clarity, whether you're understanding from where magma is being originated, what is convectional current, okay, what is liquid core. Clear? Any doubt regarding this particular thing? Another term, we use the term called geomagnetism. What is geomagnetism? Geo means what? Earth. Magnetism means what? Magnetic property. So when Earth start to show magnetic property, then it is called as what? It is called as a geomagnetism. Okay, so just note this term, geomagnetism. Geomagnetism. It is a layer that forms. It is a layer that forms the cause of. It is a layer that forms the cause of Earth's magnetic properties. No, core. Core is okay. Liquid core is the layer. No, it is the layer that forms the It is a layer that forms the magnetic. It is a layer that forms the magnetic properties of the Earth. Magnetic properties of the Earth, which is referred as geomagnetism. Which is referred as geomagnetism. It is a layer that forms the magnetic properties of the Earth, which is referred as geomagnetism. Which is the layer? Liquid core. So we discussed, okay, liquid core is the layer that is, okay, forming what? Forming the magnetic properties of the Earth. Clear? So we discussed why Earth has a magnetic properties due to liquid core and due to Coriolis force. Due to the liquid force and due to Coriolis force. So it is the liquid core, it is the layer that forms the magnetic properties of Earth, and this properties is referred as what? Geomagnetism. Clear?
So Coriolis force is in the center of the Earth.
No, Coriolis force has not existed at the center of the Earth. You feel this force, okay, whenever any rotating object is there, okay? You will feel it on surface also, you'll feel it on the interior of the Earth also. Clear? Now, let's say on the surface. Let's say on the surface, if I have to move like this, okay, to this point. Now, what will happen? By the time I'll start from here, what will happen? This point has shifted where? This point has shifted here because of the rotation of Earth, okay? So now I have to move in this direction. I have to deflect my direction to move to this particular point, okay? So this deflection is called as what? This deflection is called as a Coriolis force. Clear? I'll just show you a figure.
So it is not responsible for the division of the Earth.
It is not responsible for division of air. Wind direction is impacted by the Coriolis force. Like wind is, okay, what? Wind is moving from one high, always wind move from where to where? High pressure to low pressure. Wind always move from where to where? High pressure to low pressure. So wind always move from where to where? High pressure to low pressure. Clear? This is how the wind moves. Clear? Now let's say this region is a high pressure region. This region is a low pressure region. Now wind starts to move, okay, from this region, but by the time it is okay reaching over here, low pressure region has shifted because Earth is rotating. So okay, because of this, wind has to okay travel in this direction, and this deflection is called as what? This deflection is called as a Coriolis force. Clear? Okay, so you can see these are the pictures, okay, that is okay indicating the presence of Coriolis force. Okay, so as the earth is rotating, any object in the northern hemisphere is going to be deflected towards the right side, and any object in the southern hemisphere is going to be deflected towards what? Left hand side. Okay, so this is okay there, due to what? Due to nothing but okay Coriolis force. Okay, and Coriolis force, why it is generating? It is generating due to rotation of earth. Clear? Any doubt regarding this one? Clear? So earth is rotating from where to where? How the earth is rotating? Earth is rotating from west towards east. Okay, this is how the earth is rotating. It is not moving like this, east to west. It is not moving. Earth is rotating from where to where? From west towards nothing but okay east direction. So when earth is moving from west towards east direction, the push is towards whom? The centrifugal force is acting towards nothing but okay outward direction, towards the eastern direction. That is okay there. Clear? So when anything is in northern hemisphere, okay, then okay it is going to be deflected towards what? Right hand side. When anything is in the southern hemisphere, it is going towards okay reflected towards something but okay left hand side. This occurs due to Coriolis force. More detail Coriolis force will take up okay in the climatology, because okay climate is mainly influenced by the Coriolis force. Okay, so there we'll discuss in Coriolis force in detail. Just now for example, since I use this term Coriolis force, I just okay indicated that it is generated due to rotation of rotation of earth, and this is responsible for what? Generation of magnetic properties on the earth. Clear? More detail regarding Coriolis force will take up okay in the climatology part. Clear? Any doubt regarding this particular thing? So there we'll discuss why northern deflection, while okay right hand side deflection, while left hand side deflection. We're going to discuss okay these in detail. Clear? So now we have okay what outer core and we have inner core, that is okay there. We discuss how much is the density in mantle region. How much is the density in mantle region? No, 2900 is the distance. How much density? Yeah, in the upper mantle, this much is okay. Density in the lower mantle, how much is the density? In lower mantle, how much is the density? In lower mantle, we have written it around 5.5 gram per centimeter cube. Okay, so we discussed upper mantle, how much is the density? Density is increasing uniformly, no? So we discussed okay, it is around 60 kilometer over here, around 2900 kilometer. You are seeing density increase to 5.5 gram per centimeter cube. That we have written. Yes. In the, no, not for core. Not for core. Yeah, mantle is 2.9 to 3.3, and this is upper mantle, this is lower mantle. Okay, so that's what we discussed. Discontinuity, no? Which discontinuity we have discussed? Rapid discontinuity between upper mantle and lower mantle. So upper mantle, how much is the density? 2.9 gram per centimeter cube, and to up to 3.3. Okay, this variation is there. And lower mantle, how much it is increasing? 5.5. So this is okay, the discontinuity, that is okay, we are talking about in upper mantle and lower mantle. It is not between core and mantle. Clear? So this is okay between upper mantle as well as nothing but okay lower mantle. Now in outer core, you'll see density increase to how much? Around 9.9 to 12 point. Around 9.9 to 12.6 gram per centimeter cube. Okay, you'll see around, okay, this one. Clear? 9.9 to 12.6 gram per centimeter cube. This is okay in outer core. And inner core, how much is the density? Inner core, how much is the density? From 12.6 to 13.3 gram per centimeter cube. So this is a inner core density. Clear? So outer core density is how much? Outer density is around 9.9 to 12.6. This variation you are seeing in the inner core around 12.6 to 13.3 gram per centimeter cube. And that's why here also lies a discontinuity. Which is the discontinuity? Lehman discontinuity. Yes. So this type of discontinuity is referred as a Lehman discontinuity. Clear? So because of the change in, okay, temperature, because of change in pressure, you'll see nothing but, okay, Lehman discontinuity. Clear? Temperature, you'll see around 1000 degrees Celsius temperature at the crust. So at around 60 kilometer, how much is the temperature you are going to, okay, see? 1000 degrees Celsius. At the mantle region, that is around 2900 kilometer, you will see temperature increase up to 3500 degrees Celsius. Clear? And core region, you will see temperature increase up to around 6000 degrees Celsius. You will see temperature increasing up to 6000 degrees Celsius in the core region. Clear? So this is a variation you are getting in the case of temperature. Well, this is a variation you are getting in the case of density. Clear? Any doubt regarding this particular thing? So what we have covered? What we have covered regarding interior of Earth? Yes. Yeah, previously. This is for up to inner core. So you will see increase from 3500 to 6000. Okay. Here from mantle is over at 2900 kilometer. From here, when you are moving to outer core, inner core, up to 6000 increase you will find. Okay. So from here to here, from 3500 degrees Celsius till 6000 degrees Celsius, you will see an increase. Yep. 1000 is for crust, then this is for mantle. Fine.
So what is dynamic change mean?
Dynamic means something that is, okay, quickly changing, not static. Something that is not static is dynamic, that is constantly changing. Clear? So opposite form of static is what? Static means no change. Dynamic means what? Many changes, quick changes. Something that is changing very rapidly is dynamic. Fine.
So what is the kilometer of core?
Core, you have 6300, no? Core is how much? 6300 kilometer, the radius of Earth. Clear? Any doubt regarding this one? So what we have covered? This is crust, this is mantle, this is nothing but, okay, core. Clear? We discuss crust, outer crust, inner crust. Which discontinuity? Conrad discontinuity. Between crust and mantle, which discontinuity? Mohs discontinuity. Mantle, upper mantle, lower mantle. Lower mantle. Which discontinuity? Rapid discontinuity. Clear? Then you have what? Which discontinuity? Gutenberg discontinuity. Clear? Core consists of outer core, inner core. Which discontinuity? Lehman discontinuity. Clear? This is what we have discussed. Now crust, as we discussed, contain what? Less than 1% of mass and volume. Less than 1% of mass, less than 1% of volume. Mantle, we discussed 83% of volume, 67% of mass. And core, 17% of mass, 17% of volume and around 33% of mass. This we have covered. Now crust, we discussed, consists of what? Silicon, aluminum, but most abundant is what? Oxygen. Most abundant is oxygen. Mantle, we discuss silicate of iron and magnesium. It is consisting of silicate of iron and magnesium. Core consists of nickel plus iron. Core consists of nickel plus iron. Clear? Most abundant in the entire earth. Yes. Most abundant in entire earth is iron, followed by oxygen. So iron 34, oxygen 27. Okay, so this is okay, most abundant in the entire earth. Most abundant element in the entire earth. Clear? Now here, as we discussed, crust is from where to where? 0 to 60 kilometer. Mantle is from where to where? From 60 to 2900 kilometer, and from 2900 to what? 6300 you have, okay, what? Core. Clear? So this is okay, kilometer distance we have discussed. Now within, okay, what? Within 0 to 60 kilometer, within 0 to 60 kilometer, you'll find what? You'll find the variation in density. So outer core has how much density? Sorry, outer crust 2.3. okay, we discussed, okay, here the variation is how much? 2.3 gram per centimeter cube. In upper mantle we discussed how much? 2.9 to 3.3 gram per centimeter cube. In lower mantle how much? Yes, up to 5.5 gram per centimeter cube. And then, okay, you'll see outer core, how much is the density? Around 9.9 to 12.6 gram per centimeter cube. And here how much is there? Here how much is there? From 12.6 to 13.3 gram per centimeter cube. Clear? Any doubt regarding this one? Here maximum temperature 1000. Maximum temperature reaching to 1000. Maximum temperature up to 3500. 3500. Here maximum temperature is up to 6000 degree centigrade. Clear? Now another thing we discussed is what? Density variation, uniform, temperature variation, non-uniform. Non-uniform. Okay, so this is what you have to keep in mind with regard to the points that we have discussed, summarized in one, okay, area. Clear? Any doubt regarding this one? So these information you keep in mind. Clear? For quick revision, just keep that, okay, thing in mind. Clear? So have a break and then we'll continue. Okay. Are you finding speed more, or okay, you're able to find out speed is fine?
Yes.
And, so if at all you are not waiting, just stop. Okay. If you I'm not understanding the response, then I will be able to find.
Mm-hmm. Okay. Then after Friday. Okay. Monday to Friday, a weekday batch. Okay. Weekend batch will start on Saturday. We will repeat that. They are our department.
Ma'am, any of you have to study on Saturday and Sunday?
Sorry, sir.
Come into that. Just for the study.
The problem will be paying one of the and one of the
Yeah.
Yeah,
During those buttons, can you state in different colors?
fine. I'm not aware which one is okay going to be seen in YouTube. Okay, because
White.
okay, I'll use those colors. Fine. Now there is a news regarding this one. So in 2023, you find a news regarding this, which is Earth's core mysterious new layer formed due to surface water diving deep. Clear? So just now we discussed Earth is what? So we discussed, okay, you have, okay, what? You have inner core and you have nothing but, okay, outer core. So this is, okay, what? This is a core part that you are finding. Inner core part. This is, okay, what? Outer core part. This is a mantle region and this is what your crust region is all about. Now, a new study is saying what? New study is saying that there is another layer that is, okay, being seen over here, which is referred as what? Which is referred as a E prime layer. What it is referred as E prime layer. Clear? This is, okay, another layer that you are finding in this particular region. Clear? So in outer core, there is a coming of a new layer which is referred as a E prime layer. Clear? Now, what is this E prime layer? Why it is forming? Clear? Now you are forming this, you are finding this, you are finding this because of what? You see new mysterious layer formed due to surface water diving deep. It is the surface water going deep. This new layer is something that is, okay, being formed. Clear? So where this, okay, what? Where this layer is being seen, as we discussed, this is E prime layer. This is okay, E prime layer, which is okay being seen at this particular region. More research are going on. So you might get a question also regarding E prime layer. What is E prime layer? You might get a question. So remember that E prime layer is visible where? It is visible in the outer core. So this is your inner core, this is outer core, this is okay mantle, and this is nothing but okay crust part that is okay there. Clear? So at here you are seeing coming of a new layer which is called as a E prime layer. Now why this is okay happening? Because water is moving down. Surface water is penetrating deep into the planet. Clear? So on the surface, on the crust, you have what? You have water. Now this water is percolating, moving down in the outer core, and creating a new layer over here, which has been named as what? Which has been named as a E prime layer. Clear? Now why water is going down? Why water is going down? It is due to tectonic activity. As the plates are moving, plates are colliding. So because of this, water is something that is okay going down, and this water going down till the outer core, and this outer core is where you are finding a new layer which is referred as what? Which is referred as a E prime layer. Clear? Any doubt regarding this one? So if question comes, where do you find E prime layer? Where do you find? In the outer core region. Okay, why you are finding E prime layer? Penetration of water deeper into what? Deeper into the earth's interior, and this is the reason why you are seeing presence of what? Presence of nothing but okay E prime layer. Clear? So it is creating liquid core. You can see metallic liquid core, outermost region is where you are finding this particular layer. Clear? So what is E prime layer? You just okay note it down that water percolation due to tectonic activities, water percolation due to tectonic activities deeper inside earth, this water mixing with liquid core to create E prime layer, Yeah. This information you keep in mind with regard to what? With regard to E prime layer. Oh, this one. Is it going to come? No. It's not coming. What you have written? E prime layer. So the second point says water mixing with liquid core to create E prime layer. So first point you have written, no? Fine. Okay. Now, certain points also you have to keep in mind with regard to origin of Earth. There are certain terms that can be used. One is iron catastrophe, solidification, or rather planetary differentiation. So there are three terms. One is called as a iron catastrophe. Second is called as a planetary differentiation. Third is called as a solidification of mantle and outgassing. And we have discussed Earth's interior and Earth's crust. We have discussed made up of what? Silicon and aluminum. Silicate made up of what? Magnesium and iron. Mantle is made up of that. Silicate of magnesium and iron. And third is core. Core is made up of nickel and iron. Clear? So as we discussed, initially when the Earth was formed, Earth was very hot, and it was in molten form. It was very hot, it was in molten form. Clear? So when Earth was formed, Earth was very hot, it was in molten form. So what will happen? There is no possibility of what? There is no possibility of life at this point of time. Clear? There is no possibility of life at this point of time. Now what had happened is, second area that you are finding is a case of iron catastrophe. Now this is something that is happening. What is this iron catastrophe? The Earth's temperature increasing. Earth's temperature increasing, further increasing. Why it is increasing? Due to radioactive decay. So Earth's temperature is further increasing and reaching to the boiling point, reaching to the iron boiling point, which is somewhere around 1500 degrees Celsius, reaching to that particular level. And this event is referred as what? This event is referred as a iron catastrophe. This event is referred as iron catastrophe. So Earth is when it is formed, it is in which form? Earth, when it is formed, it is a hot molten form. With further radioactive decay, temperature started increasing. When temperature started increasing, we'll see it has reached to level of around 1500 degrees Celsius, which is which is a melting point of iron. And iron, this event is referred as what? This event is referred as a iron catastrophe. Clear? Now, as we discuss, Earth is rotating. When Earth will rotate, what will happen? Heavier element will come where? Towards the center. Light element will go where? Lighter element will go where? At the outward. So heavier element, nickel and iron, is coming towards where? Towards the center, while the lighter elements are something that are ejected out. This process is referred as what? This process is referred as a planetary differentiation. Differentiation is happening. So this particular heavier part is coming down, lighter part is something that is moving away. This differentiation is referred as what? This differentiation is referred as a planetary differentiation. Clear? Any doubt regarding this part? Yeah. You'll be getting all these, so just you can note it down. You'll be getting handouts. Okay, once Friday will get over, you'll get a handout for all these classes what we have discussed. Okay, because I'm not giving you notes, I'll give you handouts for that. Okay, so you can note it down if you want. Just what is planetary differentiation? What is planetary differentiation? The heavier element is what? Move towards center, while the lighter element will what? Move away. And this lighter element is what? This lighter element, heavier element separation is called as what? Planetary differentiation. So this lighter element and heavier element separation is called as a planetary differentiation. Clear? The third is solidification of mantle and outgassing. Clear? Now, what happens here is what happens is, when Earth further rotates, then what will happen? The water that is present in mantle region start moving towards crust region. Okay, water that is present in mantle region start moving towards crust region, and this process is referred as what? This process is referred as outgassing. Clear? This process is referred as outgassing. So when Earth is rotating, water that is present in mantle region starts to move towards nothing but the crust region, and this movement upward is called as what? This movement upward is called as a outgassing. So when water is not there, mantle is solidifying. When water is not there, liquid is not there, mantle is solidifying. So this solidification of mantle and outgassing is happening. Clear? Any doubt regarding this one? So this is how you see formation of core. mantle and crust region. That's why you see oceanic crust. Water is okay being present over there. That's why you see oceanic crust formation that is okay there. Clear? Any doubt regarding this one? So these 3 points also you keep in mind regarding origin of Earth. Clear? So when Earth was formed, what is there? Earth was in which form? It was hot molten form. That is okay there. When Earth was formed, it was in hot molten form. Because of radioactivity decay, what had happened? The temperature reached to what? Temperature reached to the boiling point of iron, and this event is referred as what? This event is referred as a iron catastrophe. Clear? Because of this, iron will also melt, and when Earth is rotating, all this heavier element like iron, nickel will come towards what? Will come towards center, while the lighter element like silicon and others will move up. That is okay there. This process is referred as what? This process is referred as a planetary differentiation process. And the third is what? Third is nothing but okay, solidification of mantle as well as outgassing. So with further rotation, water will starts to move up. With water start moving up, what will happen? This phenomena is referred as what? This phenomena is referred as outgassing, and mantle solidifies because of upward movement of water. So this is what we call as a solidification of mantle and outgassing. Clear? So this is how the Earth's interior is being formed. Clear? Any doubt regarding this one? So any doubt regarding E prime layer and how this okay event is occurring, planetary differentiation or outgassing? You might get these terms in the examination. What does outgassing means? Okay, so outgassing is nothing but okay movement of water towards okay the surface, and this is why this is occurring because of rotation of Earth only. Earth is rotating on its axis, so because of that, outgassing is something that is okay happening, which has led to solidification of a mantle region. Clear? Any doubt regarding this part? Oh, sorry, melting point. It is a melting point. Melting point of iron. Iron also will melt at this point. Clear? Any doubt regarding this one? Clear? Now we are moving to the next topic, which is rocks. Which is rocks. Clear? So remember, we just now discussed the interior of Earth, and we discussed okay interior of Earth is consisting of crust, mantle and core. But on the crust you are finding various type of rocks. So you are finding various type of rocks. What is rocks basically? How do you define the term rocks? Solid part. Any other thing? Any other than the solid part? What? How do you define the term rocks? Kind of. Then which is formed due to volcanic eruption. Yes, some rocks can be formed due to volcanic eruption, not all rock. Then in simple terms, rocks are nothing but aggregate. These are aggregate of minerals which are held together by chemical bonds. Aggregate of minerals which are held together by chemical bond. This is what we called as a rocks. Clear? So one or more minerals, okay, which are held together by a chemical bonds, okay, are called as what? Are called as nothing but okay the rocks. Now question here is, what is mineral? Minerals have different chemical composition and physical properties. Any definition? Anyone else? Okay, what is the definition for minerals? What is the definition for minerals? Naturally occurring substances. Kind of. You can say that. Any other thing? Any other thing? How do you define this term? What are examples of minerals? If you are saying minerals have a different physical properties, chemical properties, naturally occurring, How do you define the term minerals? Is iron a mineral? Is it a mineral? Is copper? Is it a mineral? So how do you define this? How do you define this? We define minerals as a something which is naturally occurring inorganic. Minerals is something which is naturally occurring and is inorganic. What is inorganic means? What is inorganic means?
Which reaction carbon.
Yeah, when even any substances do not have this hydrocarbon carbon hydrogen bond, then it is going to be called as what? Inorganic. Then it is going to be called as a inorganic. Clear? If it is present, then it is going to be called as what? Organic. If it is present, then it is going to be called as a organic. If it is not present, it is going to be called as a inorganic. Clear? So minerals are what? These are naturally occurring inorganic, and they have chemical compositions and crystalline structures. They have chemical composition and crystalline structures. Clear? So they will have a specific chemical composition as well as nothing but crystalline structures. Clear? So this is what we called as a minerals. This is called as a minerals. Clear? Sorry, I have written here naturally organic. It should be occurring. Naturally occurring. It is naturally occurring inorganic chemical composition as well as having crystalline structure. What is crystalline structure means? What is crystals? Crystals you have seen. What is crystal? Something that is hard substances. This is crystal substances, crystalline substances, that is there. Clear? So what you see is something which is naturally occurring inorganic chemical composition as well as nothing but crystalline structure. These are going to be called as what? These are going to be called as what? These are going to be called as a minerals, and aggregate of many minerals are going to be called as what? Rocks. Aggregate of many minerals are going to be called as a rocks. Clear? So when we are talking about rocks, rocks contain many minerals. It contains many minerals. Clear? Any doubt regarding this particular term? So what is a rocks? Rock is a aggregate of minerals which are held together by a chemical bond. And what is a mineral? Mineral is something that is inorganic. Mineral can have crystalline structure, it can have a specific chemical composition, and it is naturally occurring. Clear? Any doubt regarding this particular thing? Now, broadly, we classify rocks into three types, which are referred as igneous rocks, sedimentary rocks, and metamorphic rocks. So you have igneous rock, you have sedimentary rocks, you have metamorphic rock. Igneous rocks is further classified into intrusive igneous rocks, Igneous rock is further classified into intrusive igneous rock and extrusive igneous rock. Intrusive is also called as a plutonic rock. Extrusive is also called as a volcanic rock. Clear? Sedimentary rocks further classified into three different types, which are mechanically formed, sedimentary rock, chemically formed sedimentary rocks, and organically formed sedimentary rocks. Organically formed sedimentary rocks. So you have mechanically formed sedimentary rock, chemically formed sedimentary rocks, as well as organically formed sedimentary rock. These are also division. And the metamorphic rocks can be further classified into thermally induced metamorphic rocks, or dynamically induced metamorphic rock. Thermally induced metamorphic rock or dynamically induced metamorphic rock. Okay, so these are the broader classification of rocks. Rocks are classified into igneous rocks, sedimentary rocks, metamorphic rock. Igneous rocks can be further classified into intrusive igneous and extrusive igneous. Sedimentary rocks can be further classified into mechanically, chemically, and organically formed. And metamorphic rock is thermally induced metamorphic rock or dynamically induced metamorphic rocks. Clear? Okay. Now, sometimes you'll also find igneous rock division written in the form of acidic rock and basic rock. So sometimes this division also you can see acidic rock as well as nothing but basic rock. And within organically formed sedimentary rocks, you will find further division which called as argillaceous. Calcareous and carbonaceous. So you will find within organic formed sedimentary rock, you will find further division which is called as a calcareous rock as well as carbonaceous rock. Clear? And within mechanically formed, you'll see two different division. Within mechanically formed, also sedimentary rock, you'll find two different division, which are referred as arenaceous rock, and argillaceous rock. Arenaceous rock and argillaceous rocks. Clear? This is broader classification with regard to rocks that you have to keep in mind. Clear? So rocks classified into igneous, sedimentary, metamorphic. Igneous further classified into intrusive or extrusive. But sometimes you'll also find this classification, that is acidic rock and basic rock. Sedimentary, mechanically formed, chemically formed, organically formed sedimentary rock. Mechanically can be further classified into arenaceous and argillaceous rock. Organically can be classified into calcareous and carbonaceous rock, and metamorphic, thermally induced metamorphic and dynamically induced metamorphic. Clear? So this is all about concept of rocks. Now what basically is igneous rocks? The first rock that you are finding is what? igneous rock. Clear? Now, igneous rocks are also referred as a primary rocks. They are referred as a primary rock. Why they are referred as a primary? Primary means what? The first or basics. Okay, that is what we call as a primary. So primary, they are referred as a primary rock because other two rocks, whether it is sedimentary rocks or metamorphic rock, their formation depends upon who? Formation depends upon igneous rock. Depends upon whom? Their formation depends upon igneous rocks. Okay, so you can say that sedimentary rock and metamorphic rocks are formed from where? They are from igneous rocks only, and as a result, these are referred as what? These are referred as a primary rocks. Clear? So igneous rocks are referred as a primary rocks. Clear? Second thing, how it is going to be formed? It is going to be formed due to the cooling and solidification. Cooling and solidification of molten magma. It is formed due to the cooling and solidification of molten magma. Clear? So igneous rocks is formed due to cooling and solidification of molten magma. Clear? Let's say this is okay. What? This is okay. The crust. This is okay. Mantle region. As we discussed, convectional current generated in the mantle region, and this convectional current is strong. As a result, what will happen? This will rupture. This will rupture and comes out in the form of okay, what? In the form of volcanic eruption. So when this volcanic eruption happens, what will happen? Cooling and solidification of what? Cooling and solidification of molten magma. That is okay, something that is okay occurring, and this is what we call as a igneous rocks. Okay, this is what we call as a igneous rocks. Now the question here is how this cooling and solidification will happen.
So because of temperature,
How temperature difference occurs?
because matter the
Hmm.
come to crust, it will keep decreasing and it will come up.
Hmm. Hmm.
And pressure will increase density as
Hmm.
so that it will come on the surface of the
Fine. Now assume that you have boiled a milk. You have boiled a milk, clear, and you have kept it in a glass. You have boiled a milk and kept in a glass, and suppose you have okay, what? You have nothing but okay, kept something under the sun, and okay, you are bringing this particular okay water inside nothing but okay room. Clear? So there are two things you are doing. One, you have boiled a milk, and now you are transferring this milk in a glass. You have kept a okay glass of water under the sun, and you have brought this under nothing but okay room. Now the scenario here is which is going to be cool faster. Which is going to be cool faster? Is boiled milk is going to be cool faster, or the water that you have kept in the sun is going to cool faster? Why?
one there will be definite difference in the temperature of when we are boiling a milk and the size of the particles of the milk is denser than
Water.
Milk is generally denser than water.
Okay.
So the particles will be more together, but in water.
Let's say if you are saying milk is denser in water, when anything denser, what will happen? When anything denser, what will happen?
So it will take time to
No, denser. Let's say we are talking about fluids. Okay, water and milk we are talking about. Clear? If anything is denser, then it is going to what? It is going to move down. Lighter thing is going to float. The heavier is going to go down. Clear? For example, put an iron nail under the water. What will happen? It goes down. Why iron nail goes down? Denser than the water. Clear? You put a ship of iron made up of iron. What will happen? It will float. Why it will float? Why it will float? Because volume of ship is what? More. Density is what? Mass by volume. Density we have discussed. What is density? Mass by volume. So when volume of the ship increases, then what will happen? Iron nail has a very less volume. So it is more denser. Clear? The same ship, if you made it, okay, what will happen? It will float. Why it will float? Because volume is more. Volume is more, then what will happen? What will happen? It will nothing but, okay, not go down. Clear? So anything which is, okay, less denser, Archimedes principle in physics you have studied, you are going to study. So Archimedes principle says that, okay, if a denser object is there, then what will happen? It will go down. Now, if milk and water have a different density, clear, what will happen? If you are adding milk in water, what will happen? Milk should go down, water should remain what?
Change my terms.
Okay.
Consistency.
No, I'm just explaining. Then you can, okay, explain this part. Milk will go down, water will remain up, okay, because density is different, okay. But can you differentiate water from a milk? No, okay, you can't differentiate. No, by can you see by naked eye? Iron nail, if you are putting, it will go down, okay, and you can see it is going down. Can you differentiate milk with nothing but, okay, water? So not much difference is what you are going to find between density of milk and water. So that's why differentiation becomes very difficult. Clear? Now you can.
I would change my term and do consistency. So the consistency of milk is more than of water. So it will take lesser time.
Fine. As we discussed, okay, you are keeping this, okay, you are keeping this under the sun and bringing it in the room. Let's say outside temperature is around 40 degree, 45 degree, that's the maximum temperature. So it will be heated around 40 to 45 degree. Okay, maximum it will be heated. Clear? Boiled milk will be, okay, somewhere, okay, around 100 degree. Okay, so you'll have, okay, higher this temperature. Now, so to bring it down to the room temperature, and to bring it down to the room temperature, what will happen? This will cool faster as compared to what? This will cool faster. This will temperature will come down as compared to this one. But rate of cooling will be what? Rate of cooling will be different. Rate of cooling will be different. What is rate of cooling? What is rate of cooling? Yeah, speed of cooling. Time taken to cool down. Time taken to cool down is a rate of cooling. Clear? Rate of cooling of this is going to be more faster. Why? Why? Rate of cooling of, okay, boiled milk is going to be more faster. Why? It is because heat always flow from where to where? From higher body temperature to lower body temperature. The more difference in, okay, what? The more difference in the temperature, let's say 100 degree and 25 degree, the more faster will be the heat transfer, because heat always flow from where to where? From higher body temperature to lower body temperature. So more the difference in the temperature, more faster will be nothing but, okay, heat transfer. Less the difference in temperature, less faster will be nothing but, okay, heat transfer. Clear? Any doubt regarding this one? Any doubt? For example, why in winter, why do you, okay, wear more clothes? What is the reason? What is the reason why do you wear more clothes in winter? Minimize the heat transfer. Your body temperature is how much? 37 degrees Celsius. Outside temperature is around what? 10 degrees Celsius, 5 degrees Celsius. So heat transfer will takes place from where to where? Higher body temperature to lower body temperature. Your body will start to lose heat. When body will start to lose heat, what will happen? What will happen? Your body, all your body functions works at what particular temperature? All your enzymes work at a particular temperature. If fever, okay, sometimes you get fever. When your body temperature increases, what will happen? Are you able to function normally? No. So when your body temperature will also drop, what will happen? You will not be able to function normally because your body parts will not work. Clear? So that's why this heat, to avoid this heat transfer, only what you do? You wear a lot of clothes. Okay, you wear a lot of clothes to avoid this heat transfer. Clear? So rate of cooling is what? Rate of cooling will be more when there is what? When there is a more, okay, what? More difference in temperature, while rate of cooling will be a lesser difference in temperature. Now, assume magma is now coming out. Now, this magma is something that is, okay, coming out. This magma is coming out onto the surface. This is one scenario. And this magma is something that is coming out, and it is nothing but, okay, spreading below what? Below the earth's surface. So it is coming out above the earth's surface and it is coming out below the earth's surface. Clear? So two scenarios are there. Clear? Why magma will not come out onto the surface? Why magma will not come out onto the surface? convectional current is not strong enough. Okay, so we discussed convectional current has to be strong enough to break the crust and come out. Clear? If it is not strong enough, it will not break the crust and it will cools and solidifies below Earth's surface. Clear? Any doubt regarding this particular thing? So either it will nothing but okay what? Either it will nothing but okay break the crust and comes out, or it will not break the crust and cooling and solidification will happen below the Earth's surface. Clear? Any doubt regarding this particular part? Now, in which case cooling will be more faster? This scenario or in this scenario? In which case cooling will be most faster? The first scenario or in the second scenario? Second scenario, cooling will be more faster. Why? First it will be faster. Why? This is first scenario, this is second scenario. First. Why? Yeah, correct. Okay, so as we discussed here, above the Earth's surface, you're having somewhere around 25-30 degree room temperature you'll be having. While okay, magma is okay having higher temperature. So rate difference in what? Difference in nothing but okay, the temperature will be more. But just now we discussed under the crust, how much is the temperature? Like we discussed at the base of crust, how much is the temperature? 1000 degrees Celsius. Okay, let's say you assume around 300-400 degrees Celsius temperature is there when cooling and solidification is happening. So rate of cooling will be what? Rate of cooling here will be slow, and rate of cooling here will be nothing but okay, much more faster. Okay, rate of cooling here will be much more faster, while rate of cooling here will be nothing but okay, slow. Clear? Because of which here the crystal formation is okay, what? Crystal formation here is not proper because rapid cooling is happening. Here crystal formation will be nothing but okay, what? More proper because cooling process is slow. Okay, taking times to cool down. Clear? So cooling process is slow, so crystal formation here will be more. Clear? Here crystal formation will be nothing but okay, less. Clear? Any doubt regarding this one? So these two scenarios are happening with the eruption of whom? With eruption of nothing but okay, magma. So when magma is erupting, either it can break the crust and come out onto the surface, or it can cools and solidifies below the surface. So when it cools and solidifies below the surface, slow cooling will happen. Slow cooling means the rocks that is going to be formed is going to be highly crystalline in nature. When faster cooling is going to happen, then what will happen? The rocks will have less crystal formation. Clear? Any doubt regarding this one? So this type of rocks which comes and forms onto the surface is referred as what? Is referred as extrusive igneous rocks, and one which forms below the surface is called as a intrusive igneous rocks. So that is what the first classification that we have discussed. So this is the first classification. So extrusive igneous rocks are going to be formed where it is formed above the surface, and that's why they are also referred as which type of rock? Volcanic rock, because volcanic eruption is happening. Here the cooling and solidification happens below the surface. That's why it is referred as what? Plutonic rocks or intrusive igneous rocks. Clear? So intrusive igneous rocks will have more crystal formation, while extrusive will have what? Less crystal formation. Clear? Any doubt regarding this one? So that's why crystal means, just now we discussed crystal is what? So let's say anything, okay, if it cools down, what will happen? Solid, formation of solid. While water cools down, what it forms? Ice it forms, solid it forms. So crystalline means, okay, when the molecules are like this, small crystals are something that are formed, that is called as a small crystal solid. If bigger, okay, is going to be formed, it is called as nothing but okay, bigger crystalline solids. Clear? So this is how okay, you're finding crystal formation will happen. Any doubt regarding this one? So rocks that have bigger crystal in which one? Intrusive igneous rock. It will have okay, smaller crystal where? In the extrusive igneous rock. Clear? So we have written igneous rocks are referred as what? Primary rocks. Why? Because other rocks formation depends upon what? Igneous rock. It is formed due to what? Cooling and solidification of whom? Molten magma. Why this cooling and solidification happens? Because of temperature difference. So if it has happened on the surface, more difference. If it happened below the surface, less difference. Clear? The third point that you can write over here is what? So the third point you can write over here is that igneous rocks are what? What is nature? Crystalline in nature. Igneous rocks are crystalline in nature. Either bigger crystal is going to form or smaller crystal are going to be formed. These are crystalline in nature. Clear? So that is okay. Another properties of whom? Another properties of igneous rock. Fourth, it is going to be unfossiliferous. It is going to be unfossiliferous in nature. What is unfossiliferous in nature means? No fossils present. Yes, no fossils present. That is called as unfossiliferous in nature. So igneous rocks are unfossiliferous in nature. Why unfossiliferous means no fossils are something that are present. What is fossils? What is the fossils?
The decaying.
Yeah, organic material, the dead and decay material which are buried inside the earth are referred as what? Are referred as nothing but okay fossils. So igneous rocks are okay unfossiliferous in nature. Why? Why do you see it do not contains any fossils? Primary rock. Any other reason?
Because it will keep changing its form.
It is keep changing its form. Any other reason?
It is completely formed by magma.
It is completely formed by the magma. So what happens because of that? Direction is correct. What happens because of that?
The only the minerals and metal water says will be present but not the decaying materials because it is by the magma phase.
Where do you see life? Where do you see life? In the water also on the surface, no, earth surface. On the land also you see life, on under the water also you see life. Clear? These lives are present where? On the surface of earth. These lives are present where? On the surface. As you go deeper inside the earth, is life is present? No. So what will happen? This magma is coming out from where? From the earth's interior. Okay, it is not formed onto the surface. If any rocks is formed onto the surface, then what will happen? It will contain fossils. But this rocks is coming from where? This rocks is formed from where? From magma coming out from the interior of earth. Since in interior of earth there is no life, it is not going to contain any fossils. Clear? So that's why it is what? It is unfossiliferous in nature. Clear? Another points that you have to keep in mind with regard to igneous rock, that these are unfossiliferous nature. Clear? Now another thing, so what are the examples of igneous rocks? Granite is an example of igneous rock. Basalt is an example of igneous rocks. These are examples of what? These are examples of igneous rocks. Even gabbro is an example of igneous rocks. Even gabbro is something that is an example of igneous rocks. So these are okay. What? These are nothing but okay examples of igneous rocks. So igneous rocks. Which one?
The last one.
Gabbro. Gabbro is from where you are deriving lot of minerals. Like we discussed, what is rock? What definition we have written with regard to rocks? Aggregate of minerals. Aggregate of minerals is called as what? Rocks. So minerals is what? Minerals could be iron. Mineral could be what? Copper. Mineral could be magnesium. Mineral could be. So from here you are deriving what? You are deriving all these minerals. From the gabbro, from the basalt. Basalt is something that is okay rich in what? Iron. Gabbro is something that is okay rich in what? Magnesiums. Okay, so you are deriving all these minerals from where? From these rocks. Clear? Any doubt regarding this particular thing? So what is the importance? If question comes regarding importance of igneous rocks, so characteristic of igneous rocks, we have discussed what is igneous rock. Called as a primary rock or a basic rock. As a other rock formation depends upon what? Igneous rock. It is formed due to what? Cooling and solidification. It is what? Crystalline rocks. Unfossiliferous. No fossils are present because magma is coming from the interior of the earth. So interior of earth, you don't have a life. As a result, no fossils are going to be found. Examples are granite, basalt, gabbro. These are the examples of what? These are examples of igneous rocks. Clear? Any doubt regarding this one? Now, if question comes, what is the significance of igneous rocks? So what is the significance?
So one, they are the parent rock.
They are the parent rock. Yes, as we discussed, okay, your rock cycle starts from igneous rock, as these are the primary rocks. Other rocks formations depends upon nothing but okay, igneous rocks. So yeah, second is it is economically very important rocks. So first significance is what? Rock cycle starts from igneous rock. Second is it is economically very important rocks. Why it is economically very important rock? Yeah, contains high amount of minerals. Okay, so whether iron and steel industry depends on who? Iron steel industry depends upon iron. Iron is coming where? From the igneous rocks. Okay, so from interior of earth we discuss what? Interior of earth consists of your what? Iron. So this iron, when eruption is happening, is coming out what? Coming onto the surface. Okay, so whether hematite ore, magnetite ore that you are talking about, all these ores are okay formed because of what? Because of igneous rocks only. Clear? So igneous rocks are economically very important. For industrial purposes, it is very important. Clear? So whether you are deriving copper, gold, silver, iron, any type of okay things, you are okay deriving from where? From nothing but okay, igneous rocks. So it is economically very important rocks. Clear? Any doubt regarding this particular thing? So this important thing that you have to keep in mind. Clear? Another classification in the igneous we have written regarding what? Is a acidic and a basic rocks. So we discuss sometimes igneous can also be written as what? Acidic rock and a basic rock. What is the difference between acidic and a basic? pH content. Okay. Any other thing? Any other thing? Yes. So acidic and basic, you are determining based on what? Based on pH content. Now, how do we say any rock is acidic in nature or any rock is basic in nature? When it have high presence of whom? High presence of silica. If silica content is high, then the rocks is going to be what? Acidic in nature. If this amount silica content is less, then it is going to be what? It is going to be basic rock. Clear? If silica content is very high in the rock, it is going to be acidic rock. If silica content is going to be less, it is going to be basic rock. Clear? To understand why this differentiation, you have to understand another term which is called as a viscous. Anyone know what this term viscous? In physics, there is also a term called viscosity. What is viscosity? Viscous, viscosity. Anyone have heard about this term? Fluidity, kind of. Any other thing? Any other thing? No, they are different. Elasticity is okay, different. Stretching part, tensile stress. What is viscosity? Viscosity basically means resistance to flow. It is generally being seen in fluid. Fluid means what? Liquid or gases. Resistance to flow. That is called as a viscosity. Clear? Viscosity terms means resistance to flow, and it is seen in fluid, either liquid and gases. It is not a property of solid. Viscosity is not seen in solid. It is seen in fluid, either liquid or in gases. Clear? Simple term, take an oil and okay, put it on floor. What will happen? And take a water and put it on floor. What will happen? Water will spread. Okay, on oil, why? It will spread less. Why?
The density of the oil.
It is because of viscosity. Clear? So oil is more viscous in nature. It has more resistance to flow, while water is what? Water is what? Less viscous in nature. That's why it spread more. Clear? So this is what okay you have to keep in mind with regard to term viscosity. Clear? So the acidic lava are something that are what? Because of the presence of silica, these lavas are more viscous in nature. Okay, these lavas are more viscous in nature. When these are more viscous in nature, what will happen? They will not flow. Magma will not flow much. Okay, and basic lava are what? They are okay more fluid in nature. They will flow more. They are less viscous in nature. They are less viscous in nature. They will flow, and as a result, okay, what will happen? These magma will spread. Clear? Now, two scenarios again you are getting. Let's say this magma is coming out. When this magma comes out, you see the magma is not flowing, This cooling and solidification is happening near to the vent. Vent is okay from where the volcanic eruption or something that are coming out. Clear? So when cooling and solidification here is happening near to the vent. Why it is happening near to the vent? Because lava is something that is okay, high content of silica. It is acidic in nature, highly viscous in nature. It will not spread much. It will not flow much. Clear? Now the second case is okay. What? Second case is lava is something that is okay coming out like this, and it is going to spread like this. It is going to spread like this. Clear? It is okay, highly fluid in nature. So it is spreading like this. Clear? From it is cooling and solidifying away from the vent. Here cooling and solidification is happening near to the vent. Here cooling and solidification is happening away from the vent. Clear? So this type of rocks are referred as what? Basic rocks, while this type is referred as what? Acidic rocks. Clear? So whether high content of magma contains high content of silica or not. If magma contains high content of silica, then it is going to be what? It is going to be acidic rock. When it contains less amount of silica, it is going to be nothing but okay, basic rock. Basic rocks are going to what? Spread much. The acidic rock is not going to spread much. Clear? Any doubt regarding this one? So what it will form? What it will form, let's say, okay, the cooling and solidification is happening near to the vent. What it is going to form? New landform. What type of new landform? It is going to form mountains. So when cooling and solidification happens near the vent, what will happen? Mountains are formed. You are seeing, okay, the rocks are not spreading, so bigger and bigger mountains are going to be formed. Such type of mountains are referred as which type of mountain? Volcanic mountain. Such type of mountains are referred as which type of mountain? Volcanic mountain. Now if it spread like this, then what will happen? What will happen? What is going to be formed? Plateaus. So it is going to form what? Plateaus. Which type of plateaus? Volcanic plateaus. Like we say Deccan Plateau. Deccan Plateau is which type of plateau? Volcanic plateau. Deccan Plateau is which type of plateau? Volcanic plateau. Clear? Why? Because it is formed due to nothing but okay, what? Due to nothing but okay, spreading of okay, what? Spreading of nothing but okay, the lava. Spreading of lava. So which we have written examples of igneous rocks is what? Granite, basalt, gabbro, which is example of okay, the acidic, which is an example of basic. So basalt is which type? Basic. Okay, so that's why in the Deccan Plateau, which type of rocks you are going to form? Basaltic rocks. Okay, so in Deccan Plateau, which type of rocks you are going to form? Basaltic rock, because this plateau is formed due to spread of basalt, and that's why basaltic rock. Acidic rock example is what? Granite. Granite is an example of acidic. Clear? So this is another classification that you need to keep in mind with regard to igneous rocks. So igneous rocks, as we discussed, two differentiation. One is intrusive and another is what? Extrusive. So extrusive is what? Cooling and solidification will happen above the surface. Intrusive is what? Cooling and solidification below the surface. More crystalline, less crystalline. Because of what? Because of rapid cooling over here, because of slow cooling over here. Acidic rock, magma will have high content of what? Silica, and that's why it will not spread much. It is going to form which type? Volcanic mountain. While basic rock, it is going to form which type? Plateaus, volcanic plateaus, and it is going to spread much. Clear? The second type of rock is what? Second type of rock is sedimentary rocks. So we discussed sedimentary rocks are classified into three types: mechanically, chemically, and organically formed sedimentary rock. And mechanically is further classified into what? Arenaceous and argillaceous. So it is further classified into arenaceous and argillaceous, and organically is further classified into what? Calcareous and carbonaceous. Okay, so now we are coming to the sedimentary rocks. Clear? Now sedimentary rocks is formed due to weathering or erosion. Weathering or erosion of igneous rocks. Sedimentary rocks are formed due to weathering and erosion of igneous rocks. That's why we have referred igneous rocks as which type of rock? Primary rock. Yeah. What is weathering and what is erosion? What is weathering and what is erosion? Now let's say this is a rock. This rocks over a period of time will start to lose some of its upper part. This rocks over a period of time will start to lose some of its upper part. It will become like this. It will become like this. Some of the upper part of the rocks is going to be nothing but weathered. Why this weathering occurs? This weathering can occur because of what? Because of temperature. That is, it can also be occurring due to other rainfall also, biological things also. Weathering in detail we'll take up later, but right now for one example I'm giving you. One is temperature. Clear? We discuss any substance when heated, what will happen? Any substance when you heat, what will happen? Expands. Clear? Any substance when you cool it down, what will happen? Contract. Clear? So substance when heated, it is going to expand, and when it cools down, it's going to contract. Now this rock is exposed to sun. This is exposed to sun daily. During the daytime, what will happen to this rocks? During the daytime, what will happen to this rock? It will expand because heating is happening, expansion will happen. During the night time, what will happen? Cooling will happen. So this, expansion, contraction, expansion, contraction. When you stretch any material, expand it, contract it continuously, what will happen? It will breaks. So that's what happens with the rocks also. Clear? So rocks can be weathered, and this type of weathering is referred as a physical weathering because it is happening due to a physical process. Temperature is responsible. That's why when you see any railway lines and etc., you see certain gaps between the track, no, at the joint. When tracks are being joined, you see certain gaps. Why these gaps are something that are left? Because sometimes you see nothing but what expansion will happen. With this expansion will cause nothing but what cause these gaps to fill. Clear? So that's why when you observe a railway track, especially one railway track like this and another, here at the joint you'll see certain gaps or something that are left because iron will expand, because of heating that is there. Clear? So if you are not leaving this gap, then what will happen? If you're not leaving this gap, then what will happen? What will happen? Then the breaking will occur. Track itself will nothing but break down. Clear? So you leave the space for what? For nothing but expansion and contraction to occur. That is there. Clear? So this is the reason why gaps are something that are left while designing tracks and etc. because material will expand. Clear? Sometimes you see wires, electric wires. During the summers, there will be nothing but what? They'll be more loose. During the winters, what will happen? They become more straighter. Why it happens? Expansion and contraction. Clear? So when contraction will happen, they will become more straighter. When expansion will happen, they will they'll become nothing but more loose in the summer. Clear? So this is what happens with the rocks also. Rocks are exposed to different temperature and as a result weathering will occur. Now what will happen to these substances which have been weathered? What will happen to these substances? What is it? No. They become small. These can be taken away by whom? Rivers. These can be taken away by whom? Wind. These can be taken away by whom? By landslide. Let's say landslide is happening. This will material will come down. So what will happen? Different phenomena. Glaciers. Let's say glacier. These rocks are where? At the mountain. Glacier is coming down. Then what will happen? They'll also take this weathered material to the bottom. Clear? So the sedimentary rocks, as we discussed, is formed due to weathering and erosion. Erosion means what? Erosion means not only the breaking, but also transportation. Weathering is only breaking. We discuss rocks is breaking down. That is called as a weathering. But along with the breaking, when transportation is also happening, this process is referred as what? Erosion. Why this transportation is happening? This transportation is happening due to river. This transportation is happening due to wind. This transportation can happen due to glaciers, movement, and etc. That is there. Sometimes due to the gravity also. Let's say it is weathered at the the slopes, then what will happen? Let's say rock is like this, weathered at the slope, then what will happen? Under the influence of gravity, it will come down. So, okay, because of the gravity also, okay, the movement can happen, that is okay there. Clear? So these, okay, breaking plus transportation is referred as what? Is referred as a erosion. Clear? So when weathering and erosion of igneous rock happens, what is formed? Sedimentary rocks are going to form. Now, let's assume that these weathered material comes and deposit like this. This material that is weathered has been deposited like this, by nothing but, okay, let's say wind is coming and depositing these material over here. Now wind do not have energy to carry it further. Clear? Because wind also dies off, no? Okay, sometimes it flows, sometimes it doesn't flow. So wind does not have further energy to carry this material, that is okay there. Clear? Over a period of time, wind brings another layer of what? Over the time, wind brings another layer of nothing but, okay, rocks which has been broken down. Over a time, another layer. So this, okay, what? This nothing but, okay, process of deposition of material will lead to formation of nothing but, okay, sedimentary rocks. Clear? This process of deposition of sediments will lead to formation of which type of rock? Sedimentary rocks. So that's why sedimentary rocks are, okay, referred as layered rock or stratified rocks. So another properties of, okay, sedimentary rocks is what? It is a layered rock or it is a layered rock or stratified rocks. Clear? So layer by layer deposition is happening. Okay, so that's why this is called as a layered rock or stratified rock, and this process of layered rock or stratified rocks is called as a lithification process. This is referred as which process? This is referred as a lithification process. Clear? So sedimentary rocks are formed due to weathering and erosion of igneous rocks. And how it is formed? Due to lithification process, layer by layer deposition, which leads to what? Which leads to formation of sedimentary rocks. Clear?
That is what we call degradation.
Which one degradation?
The process of sediment.
No, here it is called as a degradation of rocks. When you are breaking down, it is degradation. Clear? When you are depositing, it is not degradation. It is called as what? It is called as a lithification. It is called as a lithification. Clear? Any doubt regarding this one? So what is a lithification? Layer by layer formation of rocks. Clear? Third thing, whether sedimentary rocks are going to be what? Whether sedimentary rocks are going to contain fossils or not going to contain fossils. It will contain fossils. Why? So it is okay what? Sedimentary rocks are also fossiliferous in nature. It is also which type? It is also fossiliferous in nature. What is fossiliferous? Again, it will contain fossils. Why it will contain fossils? As we discussed, it is formed on the surface. On the surface, you have life. Let's say when rivers is flowing, river may contain skeleton, no? They may contain skeleton. Now the rivers is depositing this, okay, breaking of rocks, and they can deposit also skeleton over here. Clear? So what will happen is, okay, this contains which type of, okay, what? This contains which type of minerals? It contains fossils minerals. Clear? So that's why all your coal or your petroleum, crude oil, which you are extracting from which type of rock? Sedimentary rocks. Okay, so all your coal or the crude oil, petrol, diesel, what you are getting after processing crude oil, from where you are getting nothing but, okay, that from sedimentary rock, not from igneous rock. Igneous rocks are unfossiliferous in nature. Sedimentary rocks are something that are fossiliferous in nature. Clear? Now one more thing, as we discussed, the sediments that the rivers or wind are bringing, they can bring either bigger sediments or they can also bring what? They can also bring smaller sediments. The rock that is breaking can be, a bigger part can also break down, a smaller chunk can also break down, no? Clear? So when bigger part is breaking, you can see also the rivers can bring bigger sediments, or river can also bring nothing but, okay, smaller sediments and deposit it. So either you can see smaller sediment formation, or you can see nothing but, okay, bigger sediments. Let's say this is how the sediments are being formed. Sedimentary rocks are being formed like this. So this is okay, made up of what? Bigger sediments. If it is okay, made up of like this, deposition, layer by layer deposition is happening like this, then what will happen? Smaller sediments, that is okay there. Clear? So that's why we have a two classification which we have written over here. So we have these two classification, which is arenaceous and argillaceous. Okay, so mechanically means what? Mechanically means we are talking about whether you have, okay, what, whether the rocks crystal that you have is a bigger one or smaller one. Okay, that is okay there. That is called as a mechanically formed sedimentary rock. So you can have either bigger one or you can smaller one. Argillaceous is something that is okay, what? It will be consisting of smaller one. Arenaceous means what? Bigger one. Bigger one. Okay, arenaceous means bigger one. Clear? And argillaceous means what? Smaller one. Clear? Now, two things you keep in mind. When we'll come to the soil, also we'll discuss the soil particles. The soil particles can be of two types, sandy or clay in nature. So clay soil or sandy soil. Sandy soil means what? It will have a bigger particle. Sandy soil means what? Bigger particle. Clay soil means what? Very small particles. Clay is very small. Clear? So clay particles are smaller particles. Clear? So that's why argillaceous rocks, we are saying that this is okay, what? This is nothing but okay, made up of which type of okay sediments? These are made up of smaller sediments. So that's why the example of argillaceous rocks is what? Clay stone. Clay stone is an example of which type of rocks? Argillaceous. Okay. The sandstone is an example of which type of rock? Arenaceous. Clear? Any doubt regarding this one? Sandy particles means what? Bigger particle. So bigger particle means what? Arenaceous. So example is sandstone. Clay particles means what? Smaller one. So clay stone is an example of whom? Clay stone is an example of whom, but okay, argillaceous. Clear? Any doubt regarding this particular part? So this is okay how we have classification which is called as a mechanically formed sedimentary rock. So mechanically formed sedimentary rocks means it is formed due to mechanical agent. What is mechanical agent? Wind, water, glaciers, all these are mechanical agent. So rocks that are formed due to these mechanical agent is called as what? Is called as nothing but okay, mechanically formed sedimentary rocks. Clear? Any doubt? An example of this mechanically formed sedimentary rocks can be sandstone, can be clay stone. All these are examples of whom? All these are examples of mechanically formed sedimentary rocks. Clear? Any doubt regarding this particular thing? So now come to this point. So we discussed sedimentary rocks are what? Formed due to weathering and erosion of whom? Weathering and erosion of igneous rocks. Second thing we have written what? Sedimentary rocks are formed due to layer by layer deposition. Stratified rock formed due to which process? Lithification process. Third thing we have written, they contains what? Fossils. They contain fossils in nature. So whether these rocks are economically important or not economically important? They are economically important. So sedimentary rocks are also economically important rocks. Economically important rocks, especially for which minerals? Energy minerals. We discussed all your energy minerals are formed where? All your energy minerals are found in this one, whether coal, whether other thing, all your energy minerals are found in this. Clear? Now the question here is, okay, these, let's say crude oil and etc., their deposition are going to be found where? From where you extract crude oil, from where you extract nothing but okay, gas, from where you extract even groundwater. Okay, you extract groundwater. In which type of rocks you gonna see these?
Sedimentary rock.
Sedimentary rocks. Which type of sedimentary rocks? Which type of sedimentary rocks? You are going to find this in arenaceous. Okay, you are going to find this okay in which type of arenaceous. Clear? Clear? So what difference we have written? Arenaceous formed due to bigger sediments, argillaceous formed due to smaller sediments. Example for argillaceous is what? Claystone. Example for arenaceous is what? Sandstone. Clear? Now, if things are bigger in nature, what will happen? If things are bigger in nature, what will happen? It is going to be hard in nature. Clear? If it is bigger in nature means it is going to be hard in nature. Clear? Let's say okay, you are getting nothing but okay, what you are getting a sandstone is something that is okay, hard in nature. Claystone is what? Claystone is something that is a softer in nature. Clear? Take a chalk, okay, take a chalk, and okay, what will happen is okay, what, just crush the chalk, what will happen? Powder you are going to get, the fine powder you are going to get. These fine powders are what? The smaller sediments. Whether it is softer or not softer, softer. Bigger, okay, that you see bigger chalk, okay, it is going to be what? Harder in nature, that is okay there. Clear? So that is what powdery form. When you are seeing powdery forms are going to be what? They are going to be softer in nature, that is okay there, while this is going to be nothing but okay, harder in nature. Clear? So that's why arenaceous rocks are what? They are harder in nature, they are nothing but okay, what? Softer in nature. Clear? So another difference, okay, that you are finding between arenaceous and argillaceous are what? Arenaceous are something that are harder in nature, argillaceous are something that are softer in nature. Clear? Now, if it is okay smaller, if it is smaller, let's say this is okay smaller one. Now we are talking about this smaller one. Now if you see this smaller thing like this, what will happen? What will happen? Let's say water, can it go between okay smaller thing? Yeah, it will be non-porous in nature. Clear? When you have a bigger sediments like this, water space is there, water can easily go down. Clear? But okay, when you have smaller sediments like this, okay, what will happen? Space is not there, water can't easily percolate, okay, there. Clear? So that's why argillaceous are what? Non-porous in nature, while these are something that are porous in nature. These are porous in nature. So where do you get groundwater and etc.? Where, when porous things, when things will go down, then only you can store it, that is okay there. So groundwater you are going to get, crude oil you are going to get, all these things you are going to get in which type of okay things? Arenaceous. You are not going to get these type of things in argillaceous one. Clear? Any doubt regarding this one? So if you get a question like this in the examination, you have to find which of the following is incorrect statement. Which of the following is an incorrect statement, not correct? Both 1 and 2 are incorrect. Hmm? What is a rock type in Assam? Okay, we have yet not discussed rock type in Assam. Indian geography will come, then we'll discuss rock type in Assam.
The two is wrong.
2 is wrong. See, even if you don't know, this is a common sense question. We discussed oil deposits. Crude oil is going to be found in which type of oil? Which type of rocks? Arenaceous rocks. Okay, because those rocks are porous. Okay, so even if it is written it is found in argillaceous rocks, means what? It is going to be wrong, because these rocks are what? These are rocks are non-porous. When non-porous means what? They can't contain any oil deposit. So even if you don't know, okay, whether arenaceous rocks are present or argillaceous rocks are present, this is a common sense question. Clear? So that's why UPSC prepare like this. Okay, you will get confused. Okay, which type of rocks is there in the Assam? Okay, whether arenaceous, argillaceous present? No, you don't have to think from that point. You have to think from where? Which point? Whether this rocks is porous in nature or non-porous in nature. Okay, argillaceous is non-porous, will not contain any oil deposit. So of course in Assam there is going to be what? Different. Okay, what if we are finding oil in Assam, there will be different rocks. It will not be argillaceous rocks. Clear? Any doubt regarding this one? And argillaceous rocks are what? They are softer, but they are what? Which type of? Non-porous in nature. Okay, they are non-porous in nature. So answer here is both statement are incorrect. So answer here is what? 1 and 2. Clear? Any doubt regarding this one? So this type of questions can be formed in case of examinations regarding what? Regarding nothing but argillaceous as well as arenaceous rocks. Clear? Any doubt regarding this one? So what you have to, UPSC just checks your basic concept. Okay, basic concept and awareness, whether you are aware or not. Clear? They might give you some statement like this, which you think whether I don't know which type of rocks are found in Assam and etc., whether it is correct or not. Okay, so you don't have to worry about that. If your basic concepts are clear, you'll be able to easily handle such type of statement. Clear? Any doubt regarding this particular thing? So these are differences that lies between whom? These are the differences that lies between arenaceous and argillaceous type of rock. Arenaceous are bigger sediments, argillaceous are smaller sediments. Example: harder, softer, porous, non-porous. That's why all your deposits are going to be there in these part. Clear? Any doubt regarding this one? So now we are done with mechanically formed sedimentary rock, and we discuss what is mechanically formed sedimentary rocks. The one that is formed due to wind, water and other erosion, weathering, that is mechanically formed sedimentary rocks. And arenaceous and argillaceous are the two types. The second is what? Chemically formed sedimentary rocks. Chemically formed sedimentary rocks. Okay, so these are formed due to what? Chemical. These are formed due to chemical, generally due to evaporation of certain chemicals. Evaporation of certain chemicals that will lead to formation of what? Formation of nothing but chemically formed sedimentary rocks. For example, let's say lime is mixed with water. When water evaporate, what will happen? You are going to get nothing but lime. And these are something that are found in this type of rocks, are something that are found in underground caves. These are found in underground caves, either from the roof. They are found from the roof, or either growing from the bottom. Clear? So either these are found from the roof or going from the bottom. Clear? Let's say this is a rock. Let's say this is a rock. Rainfall happens, and this is a cave. This is a cave which is below the rocks. Now what will happen is what? Rainfall is happening. What will happen? Now this is a cave. The rainfall is happening. Now water will dissolve what? Water will dissolve the minerals that are present in rock. Clear? When rainfall will happen, these minerals which is present in rock will get dissolved in water, and this water will percolate from the roof. Clear? This water will percolate from the roof. Some of this water will also drop on the ground. Clear? Some of these water will also form on the ground. But after rain over, water evaporate, what will happen? The leftover part that is there on the roof or on the ground is what? Is chemically formed sedimentary rocks. Example of this is what? Stalactite and stalagmite. These are the examples of what? These are examples of chemically formed sedimentary rock. Stalactite is what? The one that is hanging from the roof. Okay, stalagmite is what? The one that is growing from bottom is called as a stalagmite. Clear? So this is a stalactite which is hanging from the roof, stalagmite which is going from the bottom. Clear? Any doubt regarding this particular thing? So these are examples of chemically formed sedimentary rocks. Clear? Now, any one of you seen Amarnath, okay, yatra or Amarnath caves yatra? You see pilgrimage goes to Amarnath. Where it is Amarnath? Any idea? Where is Amarnath? Any idea? Near Himalayas. Yes, it is Himalayas. So you can see this. You can see this picture. Clear? So if it is hanging from the roof, it is going to be called as what? Stalactite. If it is growing from the bottom, it is going to be called as what? Stalagmite. Clear? So this is okay, the stalactite as well as nothing but okay, stalagmite that you find in underground caves. Okay, this you find in underground caves. And if you see the these are rocks only. Over a period of time, these grows. Now you can see this is okay, the deity Amarnath Yatra deity that you are finding. It is a shivling, okay, that you are finding. This is an example of what? This is an example of stalagmite growing from where? Going from the bottom. This is an example of stalagmite that is okay formed over there. Clear? So that is what okay you are finding, stalactite or stalagmite. Those are examples of what? Those are examples of chemically formed which type of rock? Chemically formed sedimentary rocks. Clear? Any doubt regarding this one? So we'll stop today at this point. Rest we'll take up in the next class. So what we try to cover today is what? Interior of Earth. What is interior of Earth? Crust, mantle, core. Crust is how much? 0 to 60 kilometer. How much is the density? 2.3 gram per centimeter cube. How much is okay the density of mantle? Yeah, can vary from 2.9 to 5.5. And lastly, core. How much is okay core density? Correct. Okay, so it can vary up to 12.6 to 13.3. That is inner core, and outer core is around 9.92. How much is a mass of okay the how much mass contribution is by mantle? 67% mass contribution and 83% volume contribution. Clear? Then we also discussed mantle is made up of what? Mantle is made up of silicate of iron and magnesium. Which is most abundant element in the Earth's crust? Oxygen. Most element in the Earth crust is oxygen. Most abundant element in the Earth is iron. Most abundant element in the Earth is iron. Clear? Then we also discussed discontinuities. What are the discontinuities? What are the major discontinuity? Moho and Gutenberg discontinuity, major discontinuity. What are the minor discontinuity? Conrad discontinuity, Rapethy discontinuity, Lehman discontinuity. Clear? Then what is the density increase? What is temperature increase? Density is uniform, temperature is non-uniform. Clear? Then how much inner core temperature that is there at the inner core? Yeah, roughly around 6,000 degrees centigrade temperature that you're going to find in the inner core. Clear? Then we discussed okay the how these layers of Earth has been formed. We discussed three processes. First is what? Iron catastrophe. The second is what? Planetary differentiation. And the third is solidification of mantle and outgassing. What is outgassing? What is outgassing? Water coming from the mantle towards top, and this leads to what? This leads to solidification of mantle region. This process is referred as what? Outgassing. What is planetary differentiation? Heavier element moving towards where? Center, and lighter element moving towards far away. That is called as a planetary differentiation. Then we discuss rocks. What is rocks? Aggregate of mineral. What is mineral? Naturally occurring, crystalline, inorganic, and what are the fourth one? Naturally occurring, inorganic, crystalline, and yeah. Okay, it has a certain chemical compositions. Clear? That is the mineral. Then we discuss rocks are classified into igneous, sedimentary, metamorphic. Igneous is what? Intrusive and extrusive. Whether cooling and solidification is happening above the earth surface or below the earth surface. Acidic or basic. Acidic means what? Silica content is high, and cooling and solidification will happen near to the vent. And okay, if it is happening away from the vent, then basic. Lastly, we discussed okay, the sedimentary rocks. Sedimentary rocks are what? Formed due to cooling and solidification of it is formed due to weathering and erosion of igneous rocks, and it can be classified into mechanically formed and chemically formed and organically formed. Mechanically formed two types, arenaceous and argillaceous. Which is porous? Arenaceous is porous, argillaceous is non-porous. Which is softer? Argillaceous is softer in nature. So that difference, okay, we have discussed. And what is the example of chemically formed sedimentary rock? Stalactite and stalagmite. If it is growing from the bottom, it is stalagmite. If it is coming from the top, stalactite. Clear? So from organically formed sedimentary rock, metamorphic rock, we'll take up that in tomorrow's class. Anybody having any doubt? Fine. Thank you. Yeah. After the Friday. Okay, once week will be over, whatever we have covered, I'll provide the notes. This is made up of ice growing with certain minerals also. This is ice and minerals also going from the bottom. Because this is okay, Himalayas are more colder. Caves are okay, caves are there, more colder. So that's why you will see nothing but okay, growing of things from the bottom in the form of ice. Okay. Along with that, minerals are also there in this cool part. It is not totally ice. Ice plus minerals that is growing. Which one? Above you have rock underground. These are formed from the under the caves. Stalactite and stalagmite are formed there under the caves. Above the caves, what is going to be there? Rocks. Okay, like you have seen Ajanta caves, Ellora caves. Okay, they are being found in hilly regions. Okay, they are found. Now you are cutting the rocks to form caves. No. So above the caves, okay, what will happen? Rocks are there. Clear? So something that is okay coming from the roof, okay, because rocks are there, water will dissolve certain minerals from the rock, and if it is coming from the roof, then okay, what will happen? It is called as a stalactite. But okay, some of this becomes heavy and falls onto the ground, and if it start to grow from the ground, then what will happen? It becomes a stalagmite. So that is okay there. Any doubt? Fine. Thank you. Thank you.